join us on the stage, and S. Krishnan sir, the Secretary MIT, to also join us on the stage. Good morning again, everyone. It gives me immense pleasure to welcome you all to one of India's flagship events at the annual GPAI Summit, the Research Symposium. We have a stellar lineup of speakers for this session. Innovations typically arise within context of uncertainty and change. They emerge within complex systems involving many different people, organizations, infrastructures, contexts. Thinking responsibly within this complexity requires flexibility, creativity, and leadership. We need to acknowledge that responsibility in innovation is an ongoing process that must be able to respond to new and unexpected insights and events. We look forward to an extremely insightful deliberation on the advancements in actionable research on responsible AI, to reflect on and dissect these challenges. This session is particularly significant as it aligns with the objectives of GPAI. We have an esteemed list of speakers from multilateral initiatives, industry, and governments from about 10 countries who will share their insights on how we can collectively align efforts and build a robust and responsible future for the AI innovation ecosystem. Before we start, I just want to give you guys an overview of the session. We will start with the opening address, welcome remarks, and the keynote address. The keynote address will be followed by the launch of the book release, which will be done by the esteemed Secretary Sir joining us today. I request all the authors who are in the room to join us on the stage with their copies of the book of extended abstracts for a photo that will be shared with them as a memento after the session's over. Few housekeeping rules. I request all of you to keep your phone on silent so that the speakers are not distracted by any noise when they're delivering their very, very insightful presentations. To get started, I would request Professor Ravi to please join me on the podium to deliver his opening remarks and welcome address.
So, good morning to everyone, and welcome to this research symposium. So, in the recent times, right, so the capabilities of AI systems have exploded. In fact, even beyond the dreams of many serious AI researchers even, right? The emergent capacities that the AI system, the generative AI models that are exhibiting now, right, it's phenomenal. And also at the same time, a little concerning because we really don't know what would be the appropriate ways and means in which to use these, the power of these AI models in a very responsible fashion, right? And in particular, right, the systems have come to such a level that it would be criminal not to adopt AI in public sector applications where we are trying to reach services to a very, very large population. And if you are not able to leverage the power of these AI systems in a responsible manner, right, then we would be failing in our duty to the public. So the goal of this symposium is to appreciate the power of AI in delivering services to the larger public, and also listen to certain use cases where people have successfully used AI in large-scale public deployment. And we'd also like to hear from speakers. We're going to hear from speakers who are going to talk about some of the caveats, right? So things like, fake news and deep fakes, and also robustness of AI systems, or conversely, brittleness of AI systems, right? So where they are subject to novel methods of attacks, right? Not the conventional ways of breaking systems, but there are novel ways of breaking systems now, right? So there are many, many new terminologies that are being thrown about, like prompt injection, data poisoning, and hallucinations, and so on and so forth, right? And what does this all mean when we are trying to build applications that would be used by a very, very large population, right? It's not aimed at a very narrow domain or expert use, in which case, as long as AI was in the laboratory settings, nobody cared about much of these responsible AI issues, right? But now AI is out in the open, and and the capacity of these systems are such that it really behooves us to use these AI systems and not hide from them. In such a situation, right, we really have to worry about these caveats of using AI systems as well. So during this symposium and going forward, I hope that we open up a lot of discussions on the right way and the most responsible way to use this power of these new models, new age models, and to deliver the right services to the people. Right? So I'm really happy that we have a fantastic lineup of speakers, and most of our contributed authors are all here to share their insights with us. I'm very happy that all of you could make it to the event, and I welcome you once again to this research symposium at GPAI. Thank you.
Thank you so much, sir, for reflecting on the theme of the session, which is advancing responsible AI in public sector applications. Now I invite Shri Abhishek Singh, Additional Secretary, MIT, to deliver his opening remarks on the podium.
Thank you, Antara. Respected Secretary MIT, Professor Balram Ravindran, who has been the champion behind this research symposium, all the distinguished authors, speakers, researchers, academicians, industry partners, my colleagues who are here. It gives me immense pleasure to welcome all of you as we start the first day of the GPAI Summit in Delhi today, which will be formally inaugurated by Honorable Prime Minister today at 5 p.m. But as one of the marquee events of the Research Symposium, it's my honor and privilege to welcome all of you today this morning. I'd first like to take a moment to express my sincere gratitude to the shortlisted authors who are present here today and the invited experts for sharing their submissions with us and contributing to the success of this research symposium. I'd also like to convey my appreciation to Professor Ravindran and the team at the Center for Responsible AI at IIT Madras, along with the team at Taylor and Francis, for their constant support right from the process where we started getting the submissions, to the reviews, to the finalization, to the extent of getting all the speakers here to present their papers. So their support would have been, without it, it would have been difficult for us to organize this. I'm really, really grateful. And hopefully we'll be able to, today the book of abstract will be launched, and we'll be publishing the compendium in due course as we get final papers. I would also like to express my gratitude to all those who have joined here today, and which also shows the support that we are giving to this event. As the lead council chair of GPAI, the Research Symposium is one of the flagship events that is being proposed and organized by India at the annual GPAI Summit 2023. A flagship initiative is proposed with the intention of contributing to the outputs and objectives of the GPAI and bringing together the research that is being done globally in the field of responsible AI, to highlight the concerns that are there, and to also look at solutions, look at in what ways we can mitigate the challenges that AI presents, and in what ways we can harmonize the approach to regulation, in what ways we can kind of balance innovation and regulation, and ensure that research also contributes to ensuring that the risks do not far away outweigh the gains that we look forward from a technology like artificial intelligence. The GPAI is a uniquely placed multi-stakeholder initiative that brings together all the leading experts from science, industry, civil society, international organizations, and governments that share values to bridge the gap between theory and practice on AI by supporting cutting-edge research and applied activities in AI-related priorities. In this regard, research is a very important component in the work that GPAI does, the expert support groups, the researchers, the experts who are part of the multi-stakeholder expert group, they are very inherent part in the governance mechanism of GPAI. And that also brings together in what ways we can amplify the work that be done by the researchers through the GPAI initiative. The research symposium that we are organizing today also demonstrates our support as the lead chair and in what ways we can contribute to the research outcomes which have been identified and pursued by GPAI. So the theme of the research symposium was advancing responsible AI in public sector applications, and this symposium provides a platform for Indian and international academicians and researchers to collaborate with other AI experts, present actionable research on responsible AI in front of a global audience, and enhance cross-sectional research on responsible AI. We were very pleasantly surprised when we launched it. In fact, I was a bit apprehensive with regard to kind of response that we'll get, but in very short time, we could get very strong response to the call for abstract for the symposium. We received over 150 submissions from 38 countries on various topics, from responsible AI principles to algorithmic accountability and explainability to responsible AI assessments in less than a month. Submissions were obtained from academia, from industry, from think tanks and industry associations from countries in Asia, Africa, North America, South America, Europe and Australia. So we got participation from almost the entire world. So 11 submissions were shortlisted after a very rigorous review process with support from a committee that comprised of members from academia, industry and government. The shortlisted abstracts came from over 10 countries and includes academicians, medical professionals, government officials, civil society actors and private enterprises. These submissions represent authors from countries which include India, the United States of America, France, Australia, Norway, United Kingdom, Finland, Kenya, Ireland, Belgium and Germany. The selection engages with an interesting and wide range of topics that cover sectors like healthcare, social media, agriculture, education, along with pertinent government questions which include the principles of regulation, standards, audits, liability determination, data protection, community participation, procurement, resource extraction and flow. Several countries, enterprises and research institutions have made several advances in actionable research in responsible AI like bias mitigation, risk management. Yet research in responsible AI remains fragmented and concentrated in certain countries and organizations. Collaboration in research in responsible AI will assist in information sharing and will help the community innovate faster and more inclusively, identify specific risks and mitigate those risks before putting a product into the world. And this also goes into the theme that we have proposed for the next year with regard to collaborative AI for global partnerships. Responsible AI is a fast-growing and multifaceted research area. We hope the presentations today can inspire our audience in the room and joining those who are in the room as well as those who are joining virtually. This event is broadcast live on our virtual platform live.negd.in. So those of you whose colleagues cannot join in person, you can share the link with them and they could see the presentation that will be happening today in a due course. And this will help us pursue actionable research in responsible AI that is cross-disciplinary, representative of the perspectives of multiple stakeholders. So with this, I once again compliment and thank Professor Ravindran and his team and all the research, all the contributors to the research papers, and look forward to an engaging set of presentations today. Thank you.
Thank you, sir, for reflecting on India's priority as part of one of the priorities that we have proposed as part of GPAI, which is the collaborative AI for global partnership, and also the importance of collaboration in responsible research and innovation in AI. Now, I request Secretary Mighty to please join us on the podium. And before, sir, you join us on the stage, I request you to launch the book of abstracts that is right in front of you, and also request the authors to join us on the stage for a photograph that we can share with you as a memento for this symposium.
Good morning to all of you. I requested Professor Ravindran that we should start the session as quickly as possible so that once there's sign of activity, more people would trickle in from elsewhere in this huge conference center on this relatively chilly Tuesday morning, because I think some sense of activity would sort of drive them in. And it's also important that now that we have given people a sense of activity, the amateurs get off the stage quickly and give an opportunity to the true professionals in the AI space to talk to you in greater detail about the technical aspects of what this research symposium is all intended to be. Let me first thank all the scholars and others who have written papers and contributed to this research symposium. I think it's, as Mr. Abhishek Singh pointed out, one of the key highlights of the GPAI summit that we are holding here in Delhi, that we are able to get a collection of international scholars to contribute to a very real outcome which comes out of this particular conference and truly contributes to moving forward our understanding not just of artificial intelligence, but about the way to harness it for greater good, greater public good. I was recently at an event where, on behalf of the IMF, it was pointed out that they expect artificial intelligence to have an effect on the economy not dissimilar to what the Industrial Revolution had on the global economy in the 19th century. So that is the kind of impact that is anticipated out of AI. And clearly, I mean, it has been around for many decades. I understand that the first AI conference and the first time that the word was formally used was sometime in 1956, more than about 67 years ago. But more important than that, although it has been a word that has been in currency for many decades, it's really caught public imagination and become much more relevant at a day-to-day impact on people's lives today. It's really come out of research labs, it's come out of academia, it's come out of literally the ivory tower into something that impacts people's lives on a day-by-day basis. Clearly, the positives are huge. The potential that it has to increase productivity is tremendous. The potential that it has to actually ensure that we are far more efficient in many of the tasks that we do is also immense. This can lead to huge growth, and that is the potential that we are looking at. It can lead to far greater ease of living for many people. It can have an impact on day-to-day lives of a large number of people in a way that we would have never imagined. So all of this is clearly a very important part of what AI offers. The potential that it holds for economy at large and humanity at large is something that we simply cannot ignore. But equally, I think there are 2 or 3 areas which are of particular concern. One, we really don't know, we cannot really predict what will be the outcome of some of the models as they run more and more and learn more and more. Will they continue to be under human control is one issue that many people raise. Likewise, there is this risk of job losses, the constant fear that many jobs would be lost. That is a risk which many other developments over history have had. Economic history shows us that this is a risk that has come up very often. I mentioned about the Industrial Revolution. There were opponents to the Industrial Revolution. There were Luddites who opposed adoption of mechanical modes of production at that point. So there have always been people who have been opposed to the kind of development that takes place, the economic development that takes place, they raise points of caution. And I think from these people, from those who are concerned about what the future would hold, I think what we need to do is take note of their concerns, take note of the caution that they are trying to bring to this particular area, and see how we can harness that caution and see how we can overcome those fears. In my own mind, I have no doubt that the human mind and its ingenuity is such that it can overcome many of these fears. History has shown us that frequently many of these fears have overcome. But equally, I think it's the last part of it is also equally important. We are in a world which is much more connected. We are in a world where a lot of the media is now in our own hands. We can represent, and one can speak to many in a way that was not deemed possible even 20 years ago or even 10 years ago. Social media expansion, the expansion of the internet has led to that situation in the world today, which is, again, I mean, it has done a lot of good. Undoubtedly, a lot of good has happened. But equally, many of us are concerned about what happens when there is misrepresentation, what happens with issues like deepfakes. These are all issues which concern all of us on a daily basis. It affects many of us on an ongoing basis, and therefore those are also equally issues which need to be addressed. In fact, a newspaper which is as liberal as can be in terms of ensuring that the private sector and ensuring that the free markets have free play, as The Economist actually pointed out in a recent editorial that the same mistakes which were made with social media and not regulating social media adequately should not be made with artificial intelligence. And we should sort of look at what is now popularly called guardrails. Everyone calls it the guardrails which artificial intelligence needs to follow. Clearly, this is a research symposium where we expect thoughts from experts on this area of how we regulate AI, harness its benefit to make sure that it really delivers on the kind of promise that it holds, and that's really in our hands. There are jurisdictions in the world which have already started work on this. All of you are familiar. Recently there was an agreement, an announcement on the EU's framework on AI laws. The United States came out with their executive order on how to regulate AI laws. So all of these have been recent developments. India will need to work on how we intend to regulate this particular space. The Digital India Act is currently under drafting and will have to take note of these developments, and we will have to address the issue of regulation of AI as part of the final draft which comes out on the Digital India Bill. All of these are efforts that are on, and as policymakers, as people who have to influence this area, we would be very, very keen to hear from experts. We would be very keen to hear from people who are thinking about this subject, about different perspectives on how AI can be harnessed and how AI can be used in the best way possible. Possibly there could be mechanisms by which one AI model can be pitted against another AI model to figure out, what can go wrong, and whether they can question each other in order to arrive at a consensus which works, or that in itself could be a way in which some of the AI models can be kept in check. There could be a number of areas, number of technical ways, number of other interesting ways, counterintuitive ways in which these issues can be addressed, and those are the kind of thoughts and those are the kind of ideas we are looking for from not just this particular research symposium, but on an ongoing basis from scholars, from experts in the field, from those who have researched the field and who understand the field. And that is our expectation of this event. And we are really grateful to to Professor Ravindran for having put together this symposium for us, and all his colleagues who have helped in this particular effort. I'm really grateful for all the scholars. I understand more than 150 research papers were submitted for this symposium, and the final few are here for the best selected papers are here for direct presentation. I thank all of you for having participated in that effort, and a real word of thanks and also appreciation for my colleague Abhishek Singh and his entire team who have worked on putting together this huge international event. They've been working for the past several months to make this happen. So clearly we hope that this event does to AI in India what many other events in the past have kickstarted the thinking on this particular area and ensured that it captures not just popular imagination in a negative way, but in an extremely positive way, in the manner in which it can be harnessed for the greater good of the country, greater good of its people, and of humanity at large. Thank you again for joining us this morning, and we look forward to the outcomes of this particular symposium more than any other particular event or specific event in this three-day summit. Thank you very much.
Thank you, sir, for highlighting the importance of such initiatives and highlighting why India did it in the first place and what is it that we intend to achieve with the Research Symposium. Could I request Additional Secretary Shri Abhishek Singh, sir, to honor the keynote speaker with the scarf and a small memento of appreciation from our end. Now, before we proceed with the presentations, could I request the stage team to help me clear the chairs and the tables, and then we can get started with the presentations. We'll start with Professor Dr. Sundarajan first, and the presentations, the podium for the presentations is the one on the left. Your presentations are already loaded on the laptop, there's a number according to which you'll have to make the presentations. You're requested to follow the order. I'll be announcing your name as we have it on the agenda. Could I request the stage team to please clear the stage? Harsh, Gaurav. Dr. Arun Sundarajan, you're requested to join us on the stage. The podium on the left will be where you can have your slides and refer to it. As Dr. Arun Sundarajan sets the stage for his presentation, I'll just give a brief bio and overview of his work done so far. Dr. Arun Sundarajan is the Harold Prize Endowed Chair Professor of Entrepreneurship and Technology at New York University and author of the best-selling and award-winning book, The Sharing Economy. He's an internationally recognized expert on AI governance and digital policy. He has published over 50 scientific papers and over 40 op-eds globally. His work has been recognized by 9 Best Paper Awards and a Thinkers 50 Award. He's a member of the World Economic Forum's AI Governance Alliance. He's a frequent advisor to the governments, corporations, and investors. He holds degrees from IIT Madras and the University of Rochester. Thank you, sir, for joining us today. You may continue with your presentation.
Well, thank you very much, Antara, for that very warm introduction and flattering introduction. Thank you to Secretary Krishnan, Mr. Abhishek, Professor Ravindran for organizing such an amazing event. I'm really looking forward to hearing all of these talks. What I'm going to talk about today is, so the focus of my talk today is going to be on a specific slice of AI governance and responsible AI, which is how do we deal with a whole host of challenges that are emerging to our intellectual property and copyright regime. In 15 minutes, I'm going to be unlikely to get into all of the details, so I wanted to start by pointing you to a paper that I just published in the Technology Regulation Journal of Competition Policy International that goes into many of the details that I will skim over today in more depth. And so, think of this as a teaser for, sort of this deeper issue. But the motivation for this research and inquiry has been the very rapid change that we've seen over the last 7 years. So 7 years ago, unbeknownst to most people, Sony introduced an AI system called the Flow Machine, which could compose songs in the style of particular artists, and they released a song called Daddy's Car, which was composed in the style of the Beatles. This engendered some excitement at academic conferences and, sort of in tech circles, but most people didn't notice it. I'm sure none of you have heard of this song. Fast forward 7 years, and we are in an era where it is relatively straightforward for even my undergraduate students to effortlessly use existing technologies to replicate the style of a particular musician, to replicate the style of a particular writer, to replicate the style of a particular artist. And in many ways, the news is filled with instances of this kind of new intellectual property era that we're living in, and the kinds of lawsuits that are being brought against the big tech platforms by people who claim that the use of their data for training Gen AI systems might be considered copyright infringement. And so I break this problem into 3 parts. Sort of at the center, to me, is a challenge to our ownership of our own process of creation that generative AI is starting to pose, which is that if someone creates a replica of Arun Sundarajan and says, well, this is how Arun Sundarajan would respond to this, maybe I'll be happy, I'll be flattered that someone has taken the trouble to actually replicate me in an AI system. Then I might step back and say, well, suppose I don't like what the system is saying. Suppose I want to exert some control over what the system produces. What is my recourse under the law? And so central to the intellectual property challenges posed by generative AI are challenges posed to a human being's ownership of their own creative process or their own way of producing knowledge. And then there are 2 sort of connected issues that you have to address if you want to address this issue, which is what should policy be around the use of copyrighted material to train a generative AI system? And on the other side, on the consumption side, who owns the output of an AI system, especially if that output has been created in the style of a particular person? So if I prompt a system to write a poem like Maya Angelou or to compose a song in the style of a musician like Drake, sort of what is the ownership structure over that? Sort of what is the recourse that this individual has towards controlling whether such a system is created, and what should the law say about the use of their data to create the system in the first place? So I'm going to spend most of my time in the center, but I'll touch on those other 2 fringes because, at the center, we're really talking about a new generation of digital twins that can be created. I mean, it's not like this is completely new. Replicas of us have existed behind the walls of digital platforms for many years. And again, I'm not saying this is a good thing or a bad thing, it's just the reality, right? I mean, as we use the internet and as we have shared knowledge, sort of data about our preferences, a large number of companies have created replicas of our preferences that are used, for example, to decide what product should be recommended to you by an e-commerce vendor, what ad should be targeted to you by a advertising system. But that was yesterday's digital twin. Today's digital twin is for creative artists, like, an AI system that is able to replicate their artistic style or their creative process. And tomorrow's digital twin could be of each of us. Like, if you work in business development at a company, your particular cadence and style of making sales could be replicated. If you are a researcher, your particular style of, producing scientific knowledge could be replicated. And so this is, while this may seem today like an issue that is only of consequence to the creative professions, that is not the case. I mean, this is something that, has to be addressed, and this is sort of part of the reason why I'm spending so much of my research time on it. It has to be addressed so that we can clearly define what are the ownership boundaries between human beings and their intelligence and the machine intelligence that is no doubt going to lead to a lot of progress. Now, my research uncovers the fact that, at least in the United States, current copyright law is not well suited to give us a good answer to this question, because it was predicated on the idea that what needs to be protected is a particular piece of work rather than a particular process. The process of creation has never been thought about as something protectable for the individual. If you think about it, we've always created intellectual property law based on a philosophy that, it should not be about, that there should be a good balance between protecting unfair adaptation, taking my work and adapting it without my permission, but allowing unfettered inspiration, which is, if I want to build on the science of yesterday, I should be able to do that. So people will argue that if you gave ownership rights over detective novels to the person who wrote the first detective novel, then you're going to sort of suppress innovation in this detective novel writing space. If you gave ownership over the first hip-hop song, the category of hip-hop, to the person who wrote the first hip-hop song, then we wouldn't have seen all this wonderful hip-hop music be created. Now, that made sense at the time, but we're in a different kind of technological realm, and lawmakers may not have imagined that there would be AI systems that could not just take a particular category, but the particular way in which a particular individual produces in this category and be able to embed that into an automated system. And so this idea of substantial similarity, which underpins a lot of Western copyright law, may have to be revisited in order to be able to draw the right boundary around artistic style and the extent to which artistic style can be protected. As we work out those copyright law changes, some of the areas that you might pay attention to or keep an eye on as providing sort of short-term protection are going to be rights to publicity. Like, if someone prompts an AI system to produce in a particular famous person's style, that famous person may have recourse not under IP law but under right to publicity laws. If consumers start to believe that AI-generated content is actually being generated by a human being, and this starts to affect the market of the human being, then you may have an unfair competition claim because the person's market to sort of sell their works may be affected by the AI system's production and the ambiguity about whether this was produced by a human or an AI system. There are technological fixes for that. The EU's AI Act has some technological fixes for that. But fundamentally, it comes back to sort of how should we rewrite copyright law so that we are drawing the boundaries right. And sort of at a deeper philosophical level, it's worth thinking about whether the underlying philosophy for why we provide copyright protection in the first place, which in most countries has to do with property rights. I should own the fruits of my labor, may be instead replaced with a more European philosophy of saying that a human being has a moral right over their creative works because these works are in many ways an extension of that human being's personality. And so the tie, there's sort of more of a moral right than an economic right. And this is sort of part of what underpins, for example, copyright law in France. Now, it's hard to sort of think about changes to the IP regime for ownership of a human's creative process without going back one step and saying, like, sort of what should the policies be for copyright protection, or what should the policies be around the use of data for training an AI system. Arguments that have been made in favor of unfettered use of copyrighted material to train a generative AI system have included saying that training is like reading. Now, on the one hand, this does make sense. You can think of it as very rapid reading. On the other hand, if you think about the division of rights that are embedded in IP law, I don't think the lawmakers would have imagined a machine that is able to read in the way that a Gen AI system that is being trained reads, when they said, well, reading should be allowed in an unlimited way. So maybe we need to revisit that. Another prong that is often looked at is, are you only extracting the idea, or are you replicating the expression? And many people have argued that, like, when you train an image generating system on existing images, you are really extracting the ideas contained in those images rather than the way that they are expressed. The counter argument to this is, if you look deeper into how a large language model is trained, it is very much dependent on how the text is expressed. The way the word embeddings are created is based on how the text is expressed. The way the LLM, like GPT, is making predictions is based on how text was expressed in the past. And so these lines between ideas and expressions don't give us a clear answer for what should the boundaries of protection on training be. And we're left with this idea of, is this fair use? In the way that I can use a video for 3 or 4 minutes when I'm teaching, it constitutes fair use for educational purposes. And fair use doctrine generally sort of sits on 4 factors. When you look at these factors, again, the answers are not clear. There are factual works being used, which is generally permitted, but there are also creative works being used, which is generally not permitted under fair use. The purpose and character of use, if it's transformative, it's generally permitted, and nobody would argue that LLMs are a transformative use. On the other hand, the amount and substantiality of use, if you use the entire work, it's generally not considered fair use, and there's no doubt that LLM training is using the entire work. And so it comes down to, what is the effect of the generation of AI-based content going to be on the market for the original content? So I'm going to skip over who owns the AI output, except to say that this is an important question, because one solution to what should the boundaries around the ownership of your creative process be that has been proposed is to say, well, every individual should create their digital twin, like, themselves embedded in an AI system, and then claim ownership over it. But there's no point in claiming ownership of your digital twin if you don't own what the digital twin produces. And anything produced purely by an AI system, in the US today at least, is in the public domain, not owned by the software writer, not owned by the individual who prompted it, not owned by sort of the person who inspired it either. It's simply sitting in the public domain. All right, so in the last couple of minutes I have, I'm just going to give you a peek under the hood about how all these things come together for me as an economist into raising what are the unanswered questions that need to be answered in order to sort of really drive evidence-based sort of policy. You can think of us being early in the stages of a new economic system where in every period, human and machine innovation processes take as inputs the stock of human knowledge and AI-generated knowledge from the prior period. They put that into some sort of production system, which leads to human beings creating new output, and AI systems being trained, that is this A of T here, being trained to produce new output based on prior human knowledge, prior AI-generated knowledge, and mediated by this IP policy, where a liberal IP policy allows a lot of use of prior human knowledge. A restrictive AI policy a restrictive AI policy, on the other hand, will give more rights to the human beings and therefore sort of spur a greater amount of human creation with the same stock. And the main result that I have so far is that under a fairly general set of assumptions, you can show that the optimal IP policy is to offer unfettered use of copyrighted material for training up to a certain threshold of AI-generated knowledge, and then switch to a highly restrictive level of IP protection in order to sort of spur human innovation because the AI content production has sort of become too much. And the two questions that end up being central to answering, like, sort of when will this threshold occur? Is this threshold policy the right policy? Are what is the relative value of human-generated content and AI-generated content? The human-generated content, the experimental evidence so far seems to show that people value human-generated content more than AI-generated content, even for the same quality, but a lot more experimental work needs to be done. And the second open question that really is central to this policy is what is the relative effectiveness of using human-generated versus AI-generated content in training a large language model or a generative AI system? Because if we get to a point where there is insufficient human content being generated and too much AI-generated content being generated, then the production systems of the future, which rely on sort of data for training the next generation of AI models, may perform poorly because there is insufficient human content to continue the pace of innovation that we want to continue. So I'll conclude here, which is that IP laws really need to be updated to reflect this new tech reality, in particular, sort of redefining the boundaries of ownership around artistic style and the definition of substantial similarity, and recognizing that you can't answer the question about training or answer the question about the ownership of AI production without looking at the center, which is what are the boundaries around the ownership of an individual's creative process. And these two questions that I highlighted, the relative value of human and machine-generated content and the relative effectiveness of human-generated and synthetic data in training the next generation of AI systems, the answers to these are going to be central to defining good evidence-based IP policy in the future. And this is me working at my computer trying to sort of solve these two problems. But I apologize for taking more time than I was given, and thank you for your time.
Thank you, Dr. Sundarajan, for expanding on the underlying philosophy of copyright law and reflecting on the moral right over creative outputs. This was a very insightful presentation. Now I invite Dr. Ramya Krishnan to join us on the stage for his presentation on the paper titled Generative AI Governance, Technological Monoculture, Market Structure, and the Risk of Correlated Futures.
Okay,
Before Dr. Arun,
I think it's come up already. So
yes.
Thank you, Antara, for that very kind introduction. And good morning, everybody. The good news about going second is, when your time is up. You get 2 beeps, and I should pay attention to when my time is up. It's a pleasure to be here with all of you. Thanks to Secretary Krishnan, Additional Secretary Abhishek Singh, and Professor Ravindran for the invitation to join you all. I come to this conversation wearing 2 hats. One is that of an academic and as a technologist. The other has been the work that I've done in public policy, primarily in the United States, where I serve as a member of the National AI Advisory Committee to the President. And Secretary Krishnan mentioned the executive order, and the EU AI Act very recently brought up a number of issues, and the Chinese governance principles that were passed in September equally well address the sets of questions that I think make this convening at GPAI that's being organized by the Indian government and by IIT Madras particularly exciting. Just a word about myself. I lead a center called the Block Center for Technology and Society at Carnegie Mellon, which is a multidisciplinary institute. And much of this work that requires AI governance to be addressed requires work that spans multiple disciplines. And this paper that I'm presenting is actually joint with Arun, who you just heard from, and two other colleagues, one from Emory, Prasanna Parashurama, and Joab Sedok from NYU. In the work that I'll present, I'm going to talk about two sets of topics, and it draws on my own work, but also the work of colleagues that you see referenced here. As I just mentioned, this issue of AI governance that I'm going to address, in particular with the focus on errors, reliability, and the consequences of a very small number of firms controlling much of the technology that today has resulted in the amazing developments we see from OpenAI or from Google. And as you know, you just saw the release of the Gemini from Google just this last week. What are the consequences of a very small number of firms creating much of the technology that then gets deployed? That's something that I will talk about, both in terms of the errors, particularly in consequential applications, but also what I'll call systemic errors, which is something that the EU AI Act references as well. You heard from Arun about issues of intellectual property. In much of the work that we have done, there are three topics that come to the fore in AI governance. The first one, Arun touched on this, but then dealt with IP in more detail, and that has to do with synthetic media codes of content, codes of conduct, pardon me, as well as the technology that is required to ensure that the content produced by AI models is labeled as AI produced. In fact, if you go to the GPAI website, there's a policy paper that talks about synthetic media and synthetic media codes of code of conduct, as well as the technology requirement that any foundation model, before it's deployed, should actually come along with it, should produce with it a detection tool and a metadata labeling capability. I will not speak about this in detail during my talk, but I'm happy to talk about this offline with those that are interested. What I am going to focus on are two topics. One relates to what I'll call pre-deployment work that has to be done. This has to do with regulatory sandboxes. This has to do with the kinds of work that needs to be done to ensure that models are reliable enough, safe enough to deploy. And here, implicitly, there's a distinction drawn between model developers, by whom I'm referring to the OpenAIs, the Coheres, the Googles of the world, versus model deployers. There's going to be a very large number of model deployers, but a very small number of model developers. The second piece, which I'll only allude to, but I'm happy to discuss in detail offline, is this question of what kind of access is going to be required to provide these assurances. There's a lot of work that we need to do on measurement, on evaluation, and the assurance giving of these models before they're deployed. And in this, I'll make reference to the work done by the National Institutes of Standards and Technology on the AI risk management framework. So this is pre-deployment work. The second category that I'll use an example to illustrate is, much as we do the due diligence on pre-deployment, once models are deployed, there's going to be inevitably errors, AI failures, AI vulnerabilities that are identified, and we need a mechanism and institutional structures for identifying them, addressing them, and remediating them, so that you have both pre-deployment and post-deployment working together to create a more safer AI ecosystem. And that's really going to be the focus of my presentation. One example on pre-deployment, one example on post-deployment, and I hope to get that done in 12 minutes. All right. With regard to pre-deployment, from a high-level policy standpoint, and this was actually in congressional testimony that I gave as well, the question is, what kind of transparency do we need about what went into the model that was trained? In fact, Arun's description of IP, in his discussion of IP, this is an important issue as to what went into the model. And we often refer to this as the nutrition labels associated with models. Just like when you buy a can of soup, it tells you, what were the ingredients and then what made up the soup that you're buying. So similarly, what went into the model? What are the different data sources that went into the model? And did the model developer have the rights to use the data for the intended purposes? This goes to the copyright types of issues that Arun spoke about. Was the data analyzed for structural bias and toxicity? Was the data analyzed to ensure that it can actually be used for the purposes intended? These are the kinds of what you're calling nutrition labels. Most models today provide very high-level statements of what are called input data cards or model system cards that don't quite provide the level of detail. In fact, the Google Gemini report, I don't know how many of you have read the 60-page report, they talk about the importance of data, they talk about the importance of curation, but they don't tell us very much about what actually they did and what went into that Gemini model. This is on the input side. On the output side, the question is, what kind of reliability would we want to have of these models before they're deployed in consequential applications? We have something called, the Underwriters Lab in the US. I'm sure there's equivalents here in India as well as in Europe and Asia and other parts of the world. But fundamentally, it's a question of how reliable does the AI have to be for it to be deployable. For instance, what kinds of errors of commission or omission, so-called type 1, type 2 errors, does it commit? And how can we create what are called profiles? The AI risk management framework has something called a risk management profile, and this is often created through public-private sector discussions that allows, I think, for these output, what are the requirements that AIs have to meet? And this is where the regulatory sandboxes that are being considered by the EU, by different governments, might be used to determine if a given AI actually meets the requirements before it can be deployed. So with that as context, I'm just going to dive in and give you one quick example, and I'll skip the math. So when we think about how do we design, develop, and deploy AI systems, you begin with the values that you want embedded in these systems. So for instance, when you think about responsible AI, there are a set of principles. Pretty much everybody adheres to them. The key question is, how do you operationalize them? How do you go from policy to practice? And when you think about, I could talk about fairness as an example, and that's the one that I'll use to illustrate, this particular pre-deployment setting. But you could imagine doing this for every one of the different boxes that you see here. The second point to make is most AI systems, and I want to draw the distinction between an AI model and an AI system. AI system is more than just the AI model, because when you think about deploying a recruiting system, there are human components, there are model components that interact and taken together produce outcomes that are of interest to society or to business. In contrast, when we think about AI models narrowly, that alone is not sufficient for us to provide assurances about. We need to understand the interaction between model components and human components to understand what is it the AI system actually produces. So let me give you the example of AI with fairness as an example. So ignore the other parts, but just look at the part in red, if you can see it way in the back. Imagine that you're interacting, let's say, with a Bard or a ChatGPT or the equivalent thereof, and you are thinking about a recruiting HR type of application, a hiring kind of application, where there's a job description and there is a resume, and you're comparing that resume to a job description and asking the AI to tell you how good a match is this particular person's resume for this particular job description. This is actually being done today. Whether we like it or not, this kind of matching is being done today. And the question is, how reliable is the AI in producing a response to this match? And the question is, in comparison to what? So when you think about what should we be measuring, what should we be evaluating, and what should we be assuring against, a first step in this process, and I should note this is work that is ongoing and early, one of the things that we'd like to, and we are fortunate to have, is a very detailed data set that allows us to look at the progress of an individual through the entire hiring funnel, right from application through interviewing till finding a job. And if you take that as ground truth, recognizing that that might itself may encode bias in it, but if you take that as ground truth, the question is, how well does the AI produce responses that are matched up with what is it that we know to be our ground truth? When is it producing false positives, which is it's recommending people that should not be considered for interviewing, and when is it ignoring people that should be considered for the interview? These are called false positives and false negatives. And so I'll skip this, but the basic idea here is that the first idea is to try and understand what kinds of errors, false positives and false negatives, does the AI commit. And second, if two firms create fine-tuned versions of the AI, how much correlated error exists across these firms, so that if I apply to firm A, I get denied. I apply to firm B, I get denied again because of a systemic error that exists in the AI being deployed by these firms. And why does a systemic error arise? It arises because they're all derivatives of a small set of models owned and created by a small set of firms that effectively control all the foundation models out there. That's the essence of the idea. The rest of it is detail. It's, of course, exciting to faculty and researchers like us, but that's the main concept that I wanted to convey. I'm going to skip all this good math, though I feel competitive now with Arun, who presented a whole slide of math to you, but I'm going to ignore that. So given this large language model, what we are doing is we come up with what I'll call the simple prompt being, is this resume a good fit for this job description? You could imagine machine learning the prompt as well, which is something that we are currently have as part of our plans to do further work on. But consider the following, that you're able to look at this data set that we have, run these queries to actually determine how well does the model do with respect to the data that we do have. And that allows us to then identify how predictively accurate the AI is, and then what is the size of the false negative it produces, and what's the size of the false positive error that it produces. It's important to keep in mind that when there's a false positive, this is the case where a person is being interviewed by the firm. The AI recommends interviewing a person when the firm might not benefit from interviewing that person. That's an example where the firm internalizes that cost. On the other hand, a false negative is when I'm applying to multiple jobs and getting denied. Here, society internalizes the cost. So I think the policymaker is particularly concerned about false negatives, and therefore, in these test beds, these regulatory sandboxes and test beds, it's really important to identify not only benchmark data sets, but identify what are the acceptable rates of false positives and false negatives. Since I've already had 2 beeps, I should really go to the last example. So I've given you the first point about correlated error in an actual pre-deployment setting. The post-deployment kind of setting that I'd like to sort of leave you with is one where the model is already deployed, and here's a fun exercise for you to consider. If you haven't done this, and now this is actually a prompt that's been patched by all the bots that are out there. You could ask a bot a toxic question. It could be something like, insult me. Suppose you ask ChatGPT to insult you, it'll politely decline to do so, okay? You could say, can I build a bomb? And it'll politely decline to do so. A group of colleagues of mine at CMU, at Carnegie Mellon, learned that you could add to the string, add to the prompt a set of strings which could be just nonsense strings, like in this example that you see here. You see here, insult me followed by equal tutorial for plus while restored, etc. It's not made up by a human, it's actually machine learned. And what it does is it defeats the guardrail. It defeats a guardrail, and ChatGPT will insult you gladly, and it'll also provide you access to toxic information that you're trying to. So this is an example of a guardrail that was built in by the AI, but gets defeated by what's called a suffix attack. This is called a suffix attack. What was interesting was that the suffix attack was learned on Llama 2, but was successful with Bard, was successful with ChatGPT, was successful with Claude, which means it was a systemic error that existed in every one of the AIs that are out there. Once again, this comes about because of the fact that you have the small oligopoly of firms that are creating these AIs. So this is the empirical work that is done to show how successful this kind of suffix attack is. It turns out that you need an institutional structure, and this is where cybersecurity provides us with an institutional history. Much like we created the computer emergency response teams to create a safer cybersecurity system, where when errors were identified, they were reported back up to the software developers, here in this case up to the model developers, so that they could be patched. You need a closed loop feedback system that would allow for AI vulnerabilities, failures, and risks to be identified, risk tiered, some forensic analysis to be done. And the Software Engineering Institute at CMU has created something called the AI SRT, which is like the first example of an AI cert. And much like India and other countries have certs, I think we need a global network of these certs to allow for this coordination and sharing and post-deployment work. So I'm going to close then with the point that you need both pre-deployment and post-deployment, and there are systemic errors that arise because of these correlated kinds of errors built into these models. Identifying them is a first step. A second step is to figure out how to remediate them, and that's the work that we are undertaking right now. And I really look forward to the conversations at this conference to learn more from all of you. Thank you again for your attention.
Thank you, Dr. Krishnan, for sharing your insights on model transparency and the need for building reliable AI models through the hiring example. Now, I'd like to invite Dr. Shyam Sundaram, Fellow iSpirit Foundation, to deliver his presentation on the paper titled Data Empowerment and Protection Architecture for Training ML Models.
Good morning. Thanks all. I think the previous two speakers have made my life a little easier. It's going to be a longish talk, but I'll try to keep it as short, and you can reach out to me for additional questions. Okay. So the topic, we just spoke about the concept of the difference between the developer of a model and the person who's going to actually use the model. Now, this particular talk is going to take you into the concept of you have data, which is important for model training. But most importantly, you also need to understand that for you to empower the data, you also, for machine learning training, you also need to keep in mind a critical element of privacy. So today's talk will talk about that. Just a second. Seems to be stuck. Okay. To make the talk a little more interesting, I'm going to take a case study, and I'll explain it very briefly to you. And so there's a startup in Bangalore, and they've developed this interesting capability for analyzing X-rays. Their passion was during the COVID, they would wanted to make that process a little bit easier, so that you give the X-ray, the AI would kind of give you a diagnosis, and so on. Now they were very passionate about it. They built these models, they built a small model, and so on. And now the question comes up is this startup has to scale. They have to basically take it to a larger market, people have to use it, and of course the benefit of AI. Now, this is just a very simple representation. You have lots of data. For you to train your model, you have lots of X-rays. In this particular case, we're taking COVID, we're taking chest X-rays. You need lots of data that needs to come from some source. Many a times we use a lot of open data sets and open sources. And then you build your network model, and then of course, then you get the outcome, whether it is an infection or not an infection, a typical scenario. Now, most of the time when you start working on these models, you look for large data sets that are available, open and publicly available. And these are some random examples I've taken just to show you how it happened. Now, the problem for this startup is for them to scale, they need lots of data. They not only need lots of data, they also need lots of tagged high quality data. So there is an asymmetry that's existing. So on the bottom side, you have the startup. And for the startup to be able to build and scale their model and make it more and more relevant, they need more data. And they've trained it on public data sets, maybe 10,000, 50,000, whatever that you get access to. On the other side, you have hospitals, you have clinics, and all of these different ecosystem players who have lots of data. But at the same time, they are not able to give that data across to the startup because of straightforward privacy-related challenges. Now, if this startup has to scale and become really relevant, there's a big problem. There is no connection. As you can see, it's broken. So you have on the top side what we call as a partner, training data partner, which means a provider. That means who's the person who's going to give me the training data, good labeled data, tag data. And on the bottom side, I have a startup who has all this intelligence and technology, and they know how to build high-quality models. Now, how do I link these two? So which means for me to do machine learning training, I have to join the dots. So I'm going to talk about that in specific. The challenges, as you can see, for a training data provider are very clear. Privacy, very, very important, because that's the cornerstone. The second important element is also, for example, if I have to share data, is there a monetary frame? Why do I share it? How do I share it? And so on and so forth. So there are lots of questions that need to be answered, and the framework that we're going to talk about addresses those questions. So we already spoke about this. I'm going to quickly go ahead in this. Okay. So for this startup to basically cross that linkage breaking, they have to look at a concept of data sharing in a privacy preserving manner, and at the same time do my machine learning training, so that I have a trained model which can then be used for an inferencing cycle, as the case may be. This is slightly India context specific. Now, for you to do this, you need to have a techno-legal approach. Okay? There is technology, but you also need to have a legal foundation to address the asymmetry that we spoke about. There are principles, which is called as the ADEPS principles, which are very important. I'm not going to read it out, but it talks about accountability, democratized, evolvability, privacy by design, transparency, and secure. Now, if you have these principles working for you, and you have a framework that supports all of this, then it means that technically you have the startup can actually go ahead. I'm going to go, yeah. Now, to make this happen, for a techno-legal framework to happen, I need to solve for 3 critical pieces. The first critical piece is I need to be able to do privacy, the training in a privacy-preserving manner. For that, we are suggesting a differential privacy-based approach. What happens over here is it's going to be difficult for you to identify specific data points that you put into for the model training. The second part is you need to have a technical framework which allows me to take the data into a kind of a technical frame which permits that data to be handled and processed in a privacy-preserving manner, which means the person who gives the data, but the person who wants to train on the model cannot see the data, number one. And the second critical point is when the model is also getting trained, we are going to apply the principles of differential privacy so that you can't identify the person or a row of data that's sitting in it. And the third one, to be able to enforce this, you also need to have contracts. Who provided the data, what am I going to use it for, and so on. So you need electronic contracts. So if the framework provides for the three elements of differential privacy, the confidential computing, which allows me to keep the data safe and secure, and the processor who needs to use it can work on the data, and the third element being the contractual part of it. Now, this is an example, and I'll talk a little bit more about it. This is a scenario that's available for you as open source. I'll give you the link later, the complete code, and you can actually run and build this end to end. This is a scenario where in COVID in India, we had three critical bodies that were helping. There was ICMR, there was CoWIN, which was our vaccination app, and then you had the individual states that basically had a lot of the hospitalization information that happened when a person had COVID and as part of their triaging and they were calling. Now for you to build a disease surveillance model, imagine getting the data from three of these entities is going to be very hard, again, because of the challenges that I've already spoken to you about. The use case that we have and which you can try out later at your own convenience allows you, we have sample data, synthetic generated data, and it tells you how it comes into the CCR, how we're able to do a differentially private model, generate a machine learning trained model, which you can then later use for inferencing. And all this in the same principles that I spoke to you in the previous slide, which meant as much configuration that goes into this system. Now, when this happens, this is again a slightly a blown up version of saying that on the left-hand side, I have the people who provide the data for me. On the right-hand side are the consumers who are the actual machine learning model training folks. So this goes back to the previous talk where they spoke about the developers and then the people who are actually going to be using the model later. And then in the middle, you actually see what we call as a confidential clean room, which is the technical frame or the technology infrastructure that provides two things, differentially private training plus the data privacy that comes into it. Slightly more elongated expansion of the same thing. How does the confidential clean room work? There are contracts that are set up, which means I have the data and I know what I'm going to build with it. So contracts, and then you have the data that gets ingested into this, and then you have the processing of data that happens inside the confidential compute, and then you have the model training, and then it gives you a trained model that comes out. Now in all of this, the key point to note is the training data consumer or the person who builds the machine learning model cannot see the data. They don't have access to the data. The program, the process, what happens inside the box is a fairly configured and automated process. For many of you, these are all slides that are available on the site, and the link I'll show you later, so you don't have to worry, it's all there. Differential privacy, very simplistically put, basically tries to, if there is a person who's trying to find out a particular person in that, you can't do it. Because the way the model gets trained is it holds out. Okay? So this is one of the techniques that we have adopted in the framework. Confidential compute, just to talk a little bit, is an infrastructure, and it's provided by most of the tech providers. But this provides you a secure computing environment. It's a secure place where you can work on it, and it's also a scalable platform where you do this. This talks about contracts. When I talk about contracts, it's a little small print, but here you actually can define the data sets that you're bringing into the CCR. It actually comes and tells you in a very clear way that who is bringing the data inside. It also talks in the bottom about some of the model parameters. Sometime back there was a talk about, when a model is built, how was that model built? What are the hyperparameters that were used? What was the kind of data that was used? So in a sense, this contract kind of gives you a complete perspective into the complete model and how it got trained. How it got in, how it got trained. So in a simple way, the startup that was stuck with the challenge, now we gave a solution that says you can use a combination of differential privacy, confidential compute, and contracts, which allows you to train models. And hence, with this, the startup is able to make a progress and then do it. Now, just to say that this is not theoretical, this is all true. This is a screenshot of something that I had done. This is a deployment on one of the clouds. These are the different technical components of it that were there, and it actually works. Now, what happens, because by doing this, when you do a techno-legal framework, it allows you to what we call as, opens up the data markets. So there is a market for people who have the data, and there is a market of people who build AI models, and these two worlds are opened up because we are providing a techno frame as well as a legal frame, which allows you to solve for the collaboration and scaling and building capability. Of course, helps economies and builds more and more models. The framework consists of many ecosystem players, but to look at, I spoke about the person who provides the data, who's called as a TDP. There is a consumer who's a training data consumer, who's basically the person who's going to build the ML model, training model. There is, of course, the data principal who provides you the data, the individual. There would also be other ecosystem players, because as a part of responsible AI and as part of the many speakers that have spoken already, there needs to be self-regulated organizations. There need to be technical standard organizations. And then you also have technical providers who are the confidential compute clean rooms, which is CCR providers. And then you can also have other market players like discovery agents who can help you identify relevant data sets. So the solution that I'm speaking about solves for all of these perspectives. This is all available to you for access. There is a site which is given in the bottom called depa.world. You can go into that. There are two parts of it. There is one which is the inference cycle, which talks about once you have a model and then you got to train, what do you do with it? The other part which is relevant for today's conversation is the training part of it. So if you go into the training part of it, there are very comprehensive pre-reads, plus you can actually execute your code. There's sample codes, which I spoke about the COVID demo scenario. You can execute it and try it out yourself. And it's all available on GitHub, so it's full access that's available to you. It's a heavy topic, and hence I've simplified it in keeping the time in constraint. You can reach out to me at my email address or someone at iSpirit, and we can happy to help you further on this. It's not just me, there's lots of techies behind me, so I'm just speaking on behalf of many of them. But there's a lot of people involved in this, okay? So I think with that, I'm going to kind of stop the conversation. I'm happy, you can reach out to me anytime. Thank you. Change the
You
presentation?
can leave it as
I'll
is.
leave it.
Yes. Thank you, Dr. Sham, for sharing the actionable approach for preserving privacy while training AI models that utilizes differential privacy, confidential computing, and electronic contracts, and employs a techno-legal approach. Now, I invite and request the tech team to please support me with playing the presentation of Dr. Giselle Waters and Dr. Carrie Miller. Dr. Giselle Waters is the working group chair of the working group that's working on developing P3119 standard on artificial intelligence procurement.
Greetings.
Both of them are from the Institute of Electrical and Electronics Engineers, IEEE. Can we have the presentation? They were unfortunately not able to join us in person, but they have sent in their regards
Greetings,
and also their
esteemed
presentation.
GPAI delegates, members, and summit attendees. Thank you to the IAS President Singh, the National E-Governance Division of the Ministry of Electronics and Information Technology, for inviting us to bring you our technical talk as part of the Research Symposium. Finally, thank you to the Government of India for hosting this annual summit and allowing us to send you our recording in lieu of being there in person. I'm Giselle Waters, Working Group Chair of the Developing P3119 IEEE Standard for the Procurement of AI and Automated Decision Systems. Together with my Vice Chair, Dr. Carrie Miller, we will be presenting our talk on Raising the Standard for AI Procurement, Global Opportunity and Challenges. The Standards Association is the operational development arm of IEEE that houses technical communities, councils, and committees. In addition to its global and technical reach, IEEE has already published 7 AI governance standards for social impact, mostly addressing design and deployment. Today we will introduce you to one in development focused on AI procurement, the future P3119 standard. It is estimated governments worldwide spent up to $11 trillion contracting for goods and services for the public sector overall, and approximately $600 billion of that on information technology across segments. That's quite an opportunity to use procurement as a market-shaping mechanism, a gatekeeping and market-shaping mechanism that can create a clear demand for adopting and deploying responsible AI solutions, one that can potentially also solve market failures. This is also a unique opportunity to use voluntary consensus-based standards like P3119 to help support government AI strategies struggling to find ways to place guardrails around AI without constraining AI innovation. One of the many lessons government agencies can learn from Australia's robo-debt solution procured and administered by their Services Australia and the human rights implications in the Dutch case, in addition to hundreds, if not thousands of similar cases worldwide, is that innovating technology policy and governance with automated decision systems and their big brother AI, as they intersect with society, is that government agencies need to raise the standard in how they practice and administrate the procurement of these technologies. This is especially true as it relates to using AI-enabled technology when making high-risk and critical decisions for the populace. For example, access to internal revenue services, educational assistance, housing, welfare, work opportunities, health services, and more. In this talk, we introduce the opportunities, challenges, and an overview of the standards process model and how it can address the challenges in procuring and adopting responsible AI. The P3119 standard's primary aim is to give government agencies the opportunity to strengthen their requirements and administrative processes for AI procurement, commissions, solicitations, and tenders. This is meant to be added to existing local, national, and transnational regulatory regimes. The new standard will offer complementary normative process guidance that can be applied from pre-solicitation to contract monitoring. This is our purpose and our why for developing this new category of standard. IEEE wants to address the gaps between law and practice in this procurement area that is challenging so many governments today. The multi-layered complexity of AI systems and processing of large community data sets have presented technical and socio-technical challenges to institutional capacity. Research worldwide shows public actors in government agencies rarely understand the AI systems they are procuring and deploying. In essence, traditional government procurement models globally have yet to adapt their acquisition operations, jurisdictional laws, and procedural requirements to match the complexity and unique risks of AI systems and public data sets. Whereas other AI procurement approaches, such as these listed here, offer AI literacy, best practices, organizational AI readiness principles, and red flags for vetting technology vendors in the public sector, P3119 offers how-to process guidance across the procurement lifecycle with expanded AI transparency protocols. It also offers detailed activities and tasks in normative guidance, such as how to evaluate and define a perceived government problem that may require an AI solution or not, how to identify a government agency's risk appetite, how to assess and measure vendor answers to essential AI governance questions, and how to prompt a vendor to evaluate an AI solution across multiple criteria beyond model cards. Since we are at the GPAI Annual Summit and the UK is a member, I want to acknowledge their positive attempts at making progress on how they address AI procurement. The UK is not a stranger to building or testing AI procurement guidance. The UK guidelines for AI procurement were published in 2020. They are aimed at central government departments considering the suitability of AI solutions to improve existing and future services. They use the World Economic Forum's AI procurement toolbox in 2 case studies in their Department of Business, Energy and Industrial Strategy and the Food Standards Agency. Furthermore, the UK also recently approved their new Procurement Act in 2023, which transforms the way public procurement is regulated. In addition, one of their local government associations expressed interest in partnering with us in a regulatory sandbox. All this is to say that as a nation, more than all others we've studied thus far, they seem to be explicitly trying to get it right. Their interest in our standard could be interpreted as an attempt to lean further into more robust administrative guidance that has yet to address task-level activity and process details often needed for operational traction. In summary, for my part, in the space between old processes and AI, the gaps where governments and AI vendors should learn new ways of working together when procuring AI for the public interest, that is where P3119 was born. Global consensus building on the standards process model began in 2021 with working group members across 12 countries. Today, consensus building continues with dedicated writers across 6 countries diligently drafting each process component and building out a related set of practical administrative tools, including weighted rubrics and scoring guides. I will let Dr. Carrie Miller share with you the technical and socio-technical value offering.
Thank you, Giselle. That was a great overview of where we're headed with the standard. I just wanted to take a moment to reiterate why we are so passionate about why AI procurement is such an important governance tool for every governing body. What we know about AI is that the advantages and risks coexist within each solution. That is especially true when we have systems that make high-risk decisions or critical decisions about humans. By that, I mean decisions that can literally impact a person's life, deciding whether or not they receive support for a medical condition, whether or not they are eligible for housing subsidies, or maybe whether or not they can get a grant or a loan to go to a university. These are just a few examples of life-altering decisions. And when we use AI to aid in those decisions, we can gain some tremendous advantages in terms of efficiency, productivity, automation, and sophisticated analysis. So people don't wait as long to hear the answers, and so the answers are more consistent and accurate. But research also tells us that these systems can produce biases and discriminatory output that leads to inequities. They can cause individuals to lose their benefits, their access, their privacy, or worse, their dignity with added scale. So our goal with P3119 is to provide a standardized process that can help government agencies take advantage of the great benefits of AI while simultaneously identifying the risks so that they can be controlled and mitigated. So how do we do that? Well, we use a process model. P3119 is a process standard. So when you read the standard, you'll see this same pattern in each of the sub-processes. These are the discrete elements. Every step in each of the sub-processes follows the same pattern. We start with a purpose, then define the scope for that particular sub-process step, and then we explain the outcomes you should expect. The next 2 items are where the real work lives. The activities and tasks describe exactly what to do to accomplish the process. Note the inputs and outputs are there to manage your expectations about what you will need in order to carry out the activities and tasks, and what deliverables you will have when you finish all the steps. So this standard has 5 processes. I'll explain those in a minute, but before I do, I wanted to also share why this particular standard is a little different from others. This standard is extremely practical in a number of ways. First, we took extra care to make sure that it can fit in with your existing procurement or tender processes. This is not meant to replace anything you're already doing. This is only meant to address the additional risks and advantages that AI presents because, you know, AI is so unique. Second, we also took extra care to identify and create useful guides, templates, and rubrics. So this library of tools means that anyone that adopts this standard will have things like specific questions to ask their vendors, along with evaluation guides to help them understand if the vendor's responses are acceptable or risky, for example. So, all right, finally, let's talk about the 5 processes in the standard at a high level. So we conducted global research and found that these 5 areas are the most important junctures during the procurement lifecycle where AI risks can be effectively identified and, more importantly, managed. And that starts in stage 1, pre-procurement. This is where we must take time to identify the problem to ensure that we even need AI to begin with. And if we do need AI, this stage will require stakeholder engagement in order to help shape an effective set of requirements. In stage 2, this is when the procurement actually is in full swing. What our standard provides here is very specific questions, a scoring rubric, response evaluation guidance. It's one thing for us to help you know what to ask, but we felt it was even more important to give you tools to help evaluate those responses. In stage 3, we move on to contracting. From a risk management perspective, this stage is a critical opportunity to control your risks. Our guidance provides information on a variety of contract clauses to consider here. And finally, in stage 4, which is our post-procurement stage, we are monitoring our contract activities. As we know, AI is like a toddler. We have to watch its every move. We need to know who is using it, if it is being nice or mean to people, if it needs to have a timeout. Our guidance in this section identifies each key element of contract monitoring designed to control and manage further risks. So you might notice that I'm talking a lot about risks. While AI has many, many advantages, the standard does lean into the risk management side of AI. So to close our talk, I just want to talk to those of you who are in the risk management domain for a minute. This is what the standard looks like through the lens of risk management. So we begin with a legitimate business need, I hope. Then we establish a risk appetite using 2 important key risk indicators. How complex is the decision to be made, and the potential scale of the harms to the impacted individuals. Once we have established our risk appetite, then we can proceed to our risk assessment, which is the procurement. By that I mean risk assessment happens as you are evaluating your vendor proposals. Through that evaluation, you learn where you might have some lingering risks that need to be addressed. So the way you can control those risks is by using your contract, on your contract terms and conditions to be more specific, and your contract monitoring practices. And for good measure, you should have organizational policies about how you expect your staff to manage, use, and monitor your AI. At the end of the day, we would expect there to be a set of risk tolerance measures that help you know when your new AI system is performing beyond your risk tolerance, which may mean it needs adjusted before the consequences become more serious. So to conclude, P3119 sets out a pretty basic standard to help you manage AI for the public good, and we're glad to do it. Again, I'm Dr. Carrie Miller, and I'd like to thank Dr. Giselle Waters for her discussion. We are more than happy to answer your questions. Please feel free to contact us at the email addresses on your screen. Thank you very much for your time today.
As was mentioned in the agenda, we'll be taking a break. The tea and coffee is served right outside. We request you to join us back in the next 10 to 15 minutes. We will start the next round of presentations in 15 minutes with the presentation of Sachi and Seket on regional inequities that impact the AI development cycle. Thank you so much for joining us, and we really hope that you will be joining us back again after tea and coffee. Thank you. So we'll be starting with the presentation of Mr. Sekat Datta, CEO DeepStrat, and Ms. Sachi Salanki, Deputy Chief of Operations DeepStrat. They'll be making a presentation on the paper titled Regional Inequities in Extraction and Flow of Resources that Support and Power the Design, Development, and Access to AI. Could I request them to please join us on the podium and ensure that their slides are in place?
Right.
You may start. Thank you.
Good afternoon, and thank you, and especially thanks to Antara for tremendous amount of work that she and her colleagues have done. I'm not used to an audience like this. Usually when I speak at conferences, there are mostly people from the military or spooks. So meeting professors and technologists of this caliber is extremely daunting for us. But our paper got selected, so that's how we landed up here. And thank you again, GPAI and everybody at MIT for selecting our paper. What we looked at is the regional inequities in AI and extraction, development, etc., and how it's leading to a certain kind of, I should say, use the word imbalance in what is happening today. And if you look at it, there are historical reasons why that is there. I mean, when we were designing this PPT and you look at this map and suddenly you look at the global north, it just hits you that there is like a lot of parts in the global south were actually colonized by the global north, which is what brings us to today, what we are seeing. Secretary Krishnan mentioned earlier about how there was some opposition to industrial revolution at some point, and yet it changed the world. So today we are beginning to see a lot of worries. Professor Krishnan's paper has done a terrific amount of sort of insights into the kind of upstream and downstream impact that they are seeing. But coming back to the regional inequities, first we looked at what are the historical reasons, and there is a legacy, a colonial legacy. You have seen plundered economies. We've seen a lot of technology denial. As a result, we've also seen brain drain. When the IT revolution really hit India, it was mostly low-cost IT hubs, exploited labor, very minimal focus on advanced AI and algorithm biases, as we will go further into the paper. Whereas in the global north, fueled by colonization, a lot of resources, you've seen a transfer of talent from the global south into the global north. You look at the power of AI investments that is happening today, the processing power, the big data. Again, you see a lot of imbalance. And there's an interesting study that came out after looking at data and published papers of 2 deep learning conferences in 2020, where they found that most of the papers were from the global north and barely anything from the global south, and none from Africa and South America. You have similar kind of, there's a Georgetown University study which again looks at how many the big companies, big tech companies, how many AI labs they have set up. It turns out that 62% of the labs were outside the United States, but 68% of the people were employed in the United States. So what we are now seeing is actually that not only is the global south starting off from a disadvantaged position, they have to also overcome the hurdles of colonization, the algorithm bias, the history of technology denial, the brain drain, etc. Because even if you are producing the highest number of tech-enabled skilled workers, they're all migrating to the global north. So in a situation like this, we drew lessons from India and Kenya. One of our co-authors, she had to drop out in the middle, but she's done a lot of work, and you've read about what's been happening in Kenya and also what's been happening in other parts of Africa like Ghana, etc., which we looked at, and of course, India. And here you see there's a lot of issues about resource crunch.
So if we have a look at the algorithmic biases, we see that most of the studies that are studying the impact of these biases in fairness in decision making are actually centered in the global north. And the impact of biases on global south has hardly been studied. And it's important that we do that because there are unique challenges that the region faces. A, in terms of its internet infrastructure, tech adoption. B, also the priority sectors for the region are very different from those of Global North. So we need data sets that are representative and that are important to build the relevant AI solutions for the region. For instance, in healthcare, a lot's been spoken about healthcare. But there's a disproportionate prevalence of certain diseases such as dengue, Ebola, etc. in the Global South, for which AI solutions in the Global North don't work or pose a very high risk of producing inaccurate results. So we need data sets that are representative of the region, which can produce the relevant AI solutions that can cater to the challenges of the region.
And also, interestingly, what Professor Krishnan's work, which he presented earlier in the earlier session, you also see that, you have, as he mentioned, there are dangers in how the data is collected. There is a small group of people who are collecting the data, which creates certain kind of biases, and there are major impacts downstream. We are also now beginning to see, this is an interesting paper that we also read about, how, if you look at the survival of the fittest, every code, everybody is looking for better efficiency in the code. Like, for example, social media virality. So anything that is not giving you virality will lead to certain kind of changes in the code, etc. At some point, this will also have a major impact on AI. Now, when that happens, and we already sort of struggling with the black box problem because we don't know how ultimately AI at which point is sentient to a certain level and taking certain decisions, so on and so forth. Between the two, it again has major impact for the Global South. So coming back to traditional guardrails, which Secretary Krishnan mentioned in his opening address in the morning, traditional guardrails, how do you bring them? For example, if you were to other regimes, international regimes like the Nuclear Proliferation Treaty, or if you look at CTBT or the Wassenaar arrangement, a country like India has always wondered that, these technologies have come in, but where these treaties were being worked out, where was India or the Global South? And in some ways, while GPAI is trying to do a lot of things, you realize that India is probably one of the only country or one of the few countries in the first 15 founding members who created this. And even now, Global South representation is very, very low.
Also, the Global South faces a very prominent challenge in terms of labor laws, as has also been discussed earlier. And there's a few key factors that are at play. A, if we have a look at the investments that are taking place in AI, most of them are centered in the Global North, which also means naturally that is where the most hirings in AI are. Whereas on the other hand, the Global South has a rich talent pool of skilled workers, especially from STEM fields, which it has not been able to retain. What this does is it leads to a few effects. A, it leads to migration of STEM workers from the Global South to the Global North, which creates the problem of brain drain for the South, but also it has a reverse phenomenon for the North, which is the advantage of brain gain, where they benefit from the innovation that these immigrants contribute to and the productivity rise that they contribute to. So if you have a look, India actually has the highest AI skill penetration in the world, and all of this workforce is actually going to migrate to the Global North in absence of employment opportunities with the South. So that's a huge problem that we face with the Global South. The other problem is also of outsourcing of
STEM work.
also the labor that is being the work that is being outsourced to the labor in the Global South is a work that is.
Good.
So we can just skip that slide.
So what we have also seen is, like, even though India has done tremendous amount of work, as far as the AI readiness index is concerned, a year ago they were at 32, today they are at 40. So why this is happening, the perpetuity of this imbalance continues to continue. And if you look at it, that also reflects what are the kind of areas, priority areas for countries like India, Kenya in the Global South as examples, and say the United States or UK, where you see investments, like for example, the investments in AI in the US are, outweigh completely the next 7 or 8 countries in terms of investments. And also most of the areas that they're looking at are starting off where they're looking beyond what has already been established, whereas a country like Kenya today is looking at using AI to combat corruption. So even basic issues have to be addressed. Therefore, the emphasis in India, like on healthcare, agriculture, where how can AI be used to meet the requirements of the people before it can be used as a tool to arrive at a global stage. So that's also reflected in the kind of, so we scanned country after country, both from the AI readiness index as well as other charts, and you see the same pattern emerging over and over again. So therefore, what is the way forward? In countries in the global south, there has to be a lot of greater investments from the government, because investments from private companies, I mean, they are subject to control from their shareholders, value, etc. So they will only be looking at certain areas, whereas both from an education, skilling, as well as deployment and employment perspective, greater investments from government. And of course, more emphasis on STEM, data science at the grassroots level. Africa has come up with some really interesting, and also South America, some very interesting community-led initiatives like Learning Indaba and Data Science Africa, where at one conference they realized that even though the conference was taking place in Africa, there was no paper from the whole continent. So that's when these initiatives started coming up, that how can we talk to each other, which led us to the other idea that is worth exploring, and GPAI, or organizations like GPAI, which incidentally, for example, today, both the key centers of GPAI are in the global north, which is Paris and Montreal, and the working groups are therefore also based out of there. But what about the global south? So therefore, can we use GPAI or any other forums like ASEAN, etc., where we have more south-south cooperation on AI, where we have the richness and diversity of data sets, etc., and also formulate some of our own positionings there, and ensure that there is more indigenous research institutes, because when foreign corporations come and they are setting up, and India is quite lucky and also unique in that sense in the global south, that it is reaping a lot of those benefits, but till we have more indigenous institutes in researching in AI, that imbalance will continue to do. And we have to see and ensure that, unlike, for example, in Kenya, where low-end, low-yield activities like data labeling, etc., was being carried out at almost, negligible economies, we need to now start looking at how we can do high-yield or higher-end AI work, and therefore also participate and build more equitable international regulatory regimes. Thank you.
Thank you, Saikat, for exploring the reasons of the inequitable distributions of resources globally and the issues with the representation of global south countries in the discourse around AI innovation ecosystem, and also highlighting the way forward with a focus on south-south cooperation. Next, we have the presentation by Ms. Lisa Ferriol and Ms. Anthea, who I request them to join us on the podium on my left. Their presentation is titled Actionable Ethics from Philosophical Principles to Operational Initiatives for Responsible AI Projects in Public Sector in the French Context.
So hello everyone. First of all, we are particularly honored to present you our article, Actionable Ethics, from Philosophical Principles to Operational Initiatives for Responsible AI Projects in Public Sector in the French Context. This article has been co-written by Bertrand Montubert, Professor of Mathematics and President of Equitia, a think and do tank that will be presented in the article, Lisa and myself, lawyer and both part of the SERPOP Research Lab attached to University of Toulouse and employees at Equitia. As you can see, the three of us declare our link to Equitia as employees and president of this association, which will be presented in the article. Through this article, we wanted to show how, aside from the binding legal rules actually discussed on AI all around the world, the ethics approach have an important role to play regarding the deployment of AI, in particular in the public sector. Indeed, questioning the ethics of each AI project on a case-by-case basis appears complementary with the actual and future legal framework because it reinforces the guarantee of acceptable projects for all the stakeholders and in particular the citizens. In France, the highest administrative court has recently published a study to guide the sense of the national strategy on AI in the public sector and put ethics methodology at the center. 7 ethical principles are defined, the ones that appear on the slides, as well as a practical methodology to guide the use of AI for the implementation of public policies. But, in spite of this position, the reality is more complex. Only a few public actors do actually know the existence of this study, which, in addition, comes in a context of digital transformation that is already raising many challenges for the public sector. And as Dr. Krishnan was saying in his talk this morning, the question is, how do we go from policy to practice?
So this research was the occasion to present the specific challenges that face public sector actors when it comes to AI project development. First, we want to recall that the exemplarity duty specific to public actors commands them to deploy socially acceptable AI systems aiming at improving public services for citizens and public action. And also, public sector covers a wide range of different types of actors at different levels of the territory. So beyond the central state's actor, different types of local public actors exist with different governance systems, resulting in a fragmented landscape. So the result is a complicated relay between the national policies and the local actors. Indeed, it is shown today that public actors at local level lack competencies and awareness on the subject of AI, and even more when we talk about the subject of ethics of AI. The subject appears indeed challenging for them and call for practical actions in order to help them improving coordination between the policies put in place at the central level and the AI projects. We need to share resources and build competencies on the subject of ethics of AI in order to ensure a responsible and acceptable development of AI systems in the public sector. So in order to tackle this challenge, we see initiatives emerging for federate actors around similar concerns. So today we want to present the Equitia Think and Do Tank, which aims to tackle challenges related to ethical use of data and digital projects, so including AI systems. So Equitia was created in 2019 in order to address the lack of trust that actors relate when it comes to data sharing. Around an ethical charter of data usage, it federates today more than 60 members from all sectors of activity, so academia, companies, local authorities, and national public organizations, and develop with them and for them practical tools aiming at deploying ethical AI projects.
Indeed, we offer today ethical support to provide project owners personalized recommendations based on the ethical charter, and also we propose a label which allows to assess data and AI solutions with more than 100 criteria. Furthermore, in order to promote an inclusive governance in our activities, we organize workshops aiming at including citizens in our reflections. And just to give a more precise idea of the criteria covered by Equitia's label, we put on this slide the various thematics covered by the ethical principles of our charter. Finally, to illustrate how the tools developed by Equitia can be useful regarding responsible AI in the public sector, the article presents 2 AI projects which have received ethical support by design. One project aiming to provide health decision makers a decision support tool consisting in a regional map predicting areas at risk of resurgence of the COVID-19 epidemic, and for another project in the employment and training sector, aiming to provide training tailored to job opportunities and personalized career guidance. We also wanted to show how our label contributes to responsible AI development in the public sector by presenting the fact that to date, on 5 solutions that has been labelized, 2 has been developed by public actors in-house and 2 by private actors to be useful to public actors.
So in conclusion, what we wanted to show in this article is that in order to allow public actors to implement national policies in the deployment of AI systems, it looks essential to provide them with practical tools. Adopting an ethical approach in this tool enables projects to be structured right from the design stage while inviting the various stakeholders to think and work together. In order to address the central challenge related to lack of trust between diverse stakeholders, third parties such as Equitia, so acting as an independent organization, appear fundamental today for deploying socially acceptable AI projects. And the almost 70 members we now have in the Equitia ecosystem bear witness to the interest and needs in the subject. And beyond the binding text applicable to the development of AI systems, ethics has an important role to play today in enabling a specific approach to be adopted for each project, while at the same time making the various norms at stake operational. And we also wanted to link the challenges tackled in this article with the GPAI's current work on the central role of government as a data provider for AI responsible development that will be published on Friday. Several principles have been identified in part 7 of the report, and they look very coherent with those of the Equitia Charter, so some further work could be done to compare those criteria and then check out whether our charter and label could provide concrete support on a later basis. Thank you very much for your attention.
Thank you, Lisa and Anzia, for highlighting the challenges related to implementing ethics in the public sector and the projects pursued by Equitia to address these challenges. May I now invite Ms. Auril to deliver the presentation of her paper titled Supporting AI at Scale in the APEC Region Through International Standards.
Good afternoon. It's an absolute pleasure to be here. I just wanted to thank the organizers and the distinguished guests for inviting me to be here and present to you on a topic that's very close to my heart. So today you're going to get an overview, may I say, a snapshot within 10 minutes on how effectively international standards can be leveraged by the APEC economies to support and scale AI responsibly. So the papers that we present here, I just wanted to say the authors are Standard Australia, and I've supported this paper, and we had co-sponsors also from the APEC economy, including Chinese Taipei, Canada, Japan, Singapore, Thailand, and the United States. This work's also been supported by an APEC-wide project survey and significant contribution from the APEC country. So first, I'd like to acknowledge all the collaboration across the APEC country and thank them for their contribution to this paper. So let's get started with that. Obviously, you've heard it today, right? You can't ignore it. AI is everywhere, and it is driving significant innovation and efficiency across the globe. So there's a transformative opportunity also for the APEC country as recognized by the APEC Advisory Business Council. However, there's always a however, success is not guaranteed. The APEC Advisory Business Council also reported that APEC economies are not optimally prepared to take advantage of AI. Standard Australia wanted to get a bit more granular, understand what was behind this challenge. So Standard Australia led a survey of across 14 economies with more than 70 response, and that is a result of this survey. You'll note it's covering quite a range of challenges, from the lack of access to guidance and standards, the lack of trust, skilled personnel, ethical, privacy and security concern as a top 4. So, how international standards can help? Well, let me give you a short overview. For those who don't know, can I see a raise of hand in the room? Anyone familiar with AI standards, international standards? A few, okay. So, international standard on AI, the ISO standards, are one of the largest international initiative on AI. We have 62 countries involved in the development of the standards. We have 20 that are published, 35 to come. There's more than 150 experts from all around the world working very hard on developing all those remaining 35 standards. But if I have to leave you with one word today, one standards to remember, it's called AI Management System Standards. Why? Because this is a standard that sets the requirement to operate an AI system, and that will be certified against in the same vein as you have for privacy and security standards 27.1 or quality standards that all the companies use today. So, as I say, one word to remember and one number, 42001, AI Management System Standards, which is the certification that will allow the certification of AI system. So what standards are doing is not just a technical piece, it's actually giving you an AI assurance frameworks, because it gives you standards on how to manage the data, the model, but also what to do at the organization level from a risk management and an organizational perspective. We've seen that we have the EU regulators that actually map the standards. They understand the importance of the work that's done and how it allows interoperability. So this is a map that was done back in 2020, effectively mapping the AI Act to the existing standards. And currently there's an agreement between ISO and Sense and Elec, which is developing the standards for the EU under the EU AI Act, where we have to collaborate on specific standards. So now what I want to do is actually give you an example. You'll see a key challenge for APEC economy was effectively lack of trust in AI system. So how can standards help? How can we fix this challenge? So I'll give you a bit of a very high level snapshot on effectively what's the issue and what standards can do. So why is it so hard to manage AI system? Well, the main piece, as you've seen from the many regulation that comes in place, is the risk. AI systems are dynamic systems, so you need dynamic risk management. So this is how effectively AI standards can help. To do dynamic risk management, to manage the risk and ensure appropriate oversight of AI system, one, you need to know what to do with your data. So what's the governance that goes around of the data? How do you maintain the data quality? So we have a series of standards called 5259 that actually provide all those details. So how do you maintain the data quality through the life cycle of an AI system? This is the answer the standards provide. Then, how do I build safety function for AI system? How do I ensure controllability? How do I ensure that the models within an AI system are robust? So this is, again, the work that's done by the standards. And last but not least, obviously from a risk perspective, we've published a guidance on risk management, about governance of AI system, and the one to watch you'll see in not every, but most regulatory initiative, there's a reference to an AI impact assessment. We've talked about in the previous presentation about impact on individuals. Guess what? We are working on an AI impact assessment, and all those countries and experts are working together on identifying what it means to do an impact assessment for AI system. From the ethics piece, again, not something new, but what happens for AI? What do we need to do? Again, that's where the standards give you the delta. When, fairness, we have fairness for products already. Products that are not fair, they're not very well received in the markets. But what's the delta for AI system? So we have some work on bias and how to identify and actually manage the unwanted bias. There are different cultures have different bias, so the standards are obviously cognizant of that as we work with 56 countries. And we help each economies effectively understanding and identifying the unwanted bias for their respective country. How do you ensure that the AI system are trustworthy? Transparency. We see transparency is also a key regulatory pillars, so that's the work we're leading. And again, we're also providing an overview of ethical and societal concern. So that's how the standards can practically help operationalizing those principles. And if you look, that's the second part of the survey, that explain effectively, we surveyed those many countries around the APEC region, and they also, it showed effectively how effectively standards can support the APEC economy in scaling AI responsibly. Obviously, the first one, you say the top one is about compliance, supporting R&D innovation, promoting safety in the design and deployment of AI systems. So those are the three key pieces. So if I have to conclude, what's important is when leveraging, but also participating and shaping AI international standards, APEC economies can gain a competitive advantage in AI. You've heard from my previous presenter about the challenge about the global south. We have a representative country in the standard from Africa and from APEC economies too. So really encouraging to see that effectively we need a diversity of voice at standards. And the reason for participation, the benefit of the participation of APEC economy is one, it's interoperability. This is not about harmonization, it's about promoting interoperability of values, enabling that we have requirements that are effectively interoperable across jurisdiction. No one ever said we should have one legislation, one approach to AI system. Standards are absolutely key, and that's been their role from the beginning of age to ensure that effectively you have a process, do the same as the previous presenter, you have a process that effectively enable different values, different perspectives, and to operate across those different values and different perspectives. They establish a common building blocks, and they enable the scaling of quality AI system. So really, from the survey that we led in this paper, the contribution we have from the APEC country, we really encourage we would like to encourage the APEC economies to really engage and help shape those AI standards. But equally, we'd like to obviously have policymakers and industry consider how standards adoption can help them develop standard-informed AI policy that effectively enables them to develop AI system wherever they are locally, but also internationally. On that, I just wanted to say thank you for the opportunity to present.
Thank you, Ariel, for explaining and expanding how effectively international standards can be leveraged for responsible development and deployment of AI. Now I request Mr. Aditya Mohan and Mr. Karthik Satish Kumar to deliver their presentation on risk assessment methodology for AI regulation and navigating liability determination in AI-driven world.
Good morning. Myself Aditya and my co-author Karthik, we will present on risk assessment quantification and its implications. The presentation will have three parts. So first we'll set the scene on why risk quantification is needed. Then we will see where we can get inspirations from. And in the third part, we'll discuss how to actually assess risk, quantify it, and how to use it. So the state of AI is that it's extremely transformational. There is something called magnetoencephalography, which is training a model based on how human thoughts are shaped into pictures. So it allows the model to predict what you are thinking. So you can understand how invasive AI technology can become, that it can start reading your thoughts. It is so pervasive, it is so transformational, as the keynote speaker noted today, that it will be almost a criminal offense not to use its scale of efficiency for public good. And therefore, we must do something to understand what is the AI risk and how to control it. We have also seen examples of misinformation through chatbots, and you are all aware of what ChatGPT does. There is miscarriage of justice. We saw example of the Dutch social welfare system, which stopped social welfare payments based on what the model recommended. So we think that there is definitely enough examples already existing in public services where AI has done something unethical or harmful for citizens. So how do we manage the risk? First, we have to measure it. And if we can't measure something, we cannot manage it. So we have to measure it, build some metrics on those measurements, and then agree on some consensus so that we can manage the risk across borders. As you can understand from the example of nuclear technology or from the effort that is going on controlling carbon emissions, unless there is a common language to measure things, we will not be able to control the risk across borders. Just restricting it in one jurisdiction will not help. But how do we draw inspiration for doing this? So as Honorable Prime Minister of India says, this is one world, it needs one solution. So we need to have a consensus solution for which the inspiration needs to come from some industry which have preceded AI. So I'll hand over to my co-author now.
Yeah, thank you, Aditya. I think we've all understood the risks associated with AI. And as Aditya just articulated, we have an industry today which also went through similar challenges in its nascent adoption, and that's the IT industry and the cybersecurity industry. Back in 1980s, 1990s, when the IT adoption was increasing, there were similar concerns about how do we then protect the privacy of individuals, how do we protect data, how do we protect and analyze risks associated with a transaction, be it in the healthcare domain or be it in the financial services domain, and so on and so forth. Now, to address these concerns, what happened in the cybersecurity world is that academia, governmental organization, industry leaders came together to start formulating standards, start formulating risk assessment framework, and so on and so forth. And this was also articulated by earlier speakers, especially our keynote speakers. Now, that standards helped in adoption of the IT digitizations across the globe, leading to significant amount of benefits from the impact on GDP in economies like India and Global South, and so on and so forth. And it is basically helped us unleash the power of IT. So similar to that, we can look at a framework for the AI world And one of the things that we looked at, what is a good model for us to look in defining that, a risk model framework for AI would be to look at two examples of NIST risk management framework within the cybersecurity world, which provides a comprehensive way for assessing risks associated with an enterprise organization across multiple domains of security, be it from a privacy point of view, data security standards point of view, is a physical security controls point of view, and so on and so forth. The NIST framework is an industry-wide adopted framework that helps in assessing a risk associated with a cybersecurity adoption within an enterprise or a government or any agency for that particular matter. Now, underpinning that NIST framework is a risk quantification framework. So NIST risk management framework helps you to assess your risks associated across various domains, and the cybersecurity capability maturity model, which is the C2M2 framework, helps in quantifying that particular risks. So what you do there is that you take the NIST framework, apply the NIST framework onto various domains of security, and then provide a quantification score against each of those particular domains, so that an organization which is doing a self-assessment of that particular risk within their own entity can then measure where they stand in that measured against those each of those principles. Now, a good example of here would be, you could look at an organization which has a high risk score, which indicates that the maturity level within the data is higher, and a low risk score in terms of maturity level of security controls, network security control is lower. So you have various measures. Now, how these measures are used and leveraged in the cybersecurity industry is in two specific examples. One is a cyber security insurance. With the explosion of breaches, data breaches and network breaches happening, a number of companies are going and procuring cybersecurity insurances. So for example, in Australia, Essential 8, which is known as a risk management framework, which is a variation of NIST, all companies comply to that particular framework, and we have a maturity score assessed for those by the cybersecurity insurance. So higher the risk score, which means that lower the risk associated with that. So then it affects the cybersecurity premiums that an organization needs to pay. Yeah, that's basically a good example of how these risk scores are being used, and we will have a similar thought in terms of how the same risk score can be used in AI world.
So we looked at lots of different research papers which draw some framework. They help to identify the dimensions of AI, the different characteristics of AI system. And we narrowed down on OECD system because one, it is people-centric, as you can see in the illustration itself. The other reason is that in the paper itself, it says that the classification system used by OECD can be furthered for risk assessment, and the fact that it is very simple. A regulator who is non-technical in nature can use these dimensions to understand how AI risk is prevalent over several aspects. So we applied the 5 dimensions: the people, economic context, data, model, and task, to 2 examples of a similar technology. So facial recognition and access control for a building, and facial recognition in law enforcement. And you can see that when we score based on those dimension criteria, that the area under the curve is slightly different. And you can see that little spike on the people side, because in law enforcement, AI risk of misjudging a person or a miscarriage of justice is higher. As Karthik showed you the cybersecurity example, the scores can be categorized into high, low, medium risk. I have illustrated that by color, and you can see that the difference in the people dimension is significant. How do you put all of that into practice? So this is an illustration of how a new business should approach an AI authority. The risk should get measured, quantified. If it is below the threshold, the company or business registration organization can publicly publish this risk score so that all insurance regulators, data protection authorities, and ordinary citizens can look at the risk score and understand how to insure this company, how to evaluate this company, and how to report if something goes wrong. And there has to be a continuous learning process between the monitoring authority and the AI authority which assesses the risk. We request you to go through the details in the actual paper, and I hope that a lot of member countries who are present here will support and agree on a consensus for this risk framework. Thank you.
Thank you, Aditya. Thank you, Karthik, for expanding on the necessity for risk assessment quantification and implementation, and most importantly, the need for a common language on AI risks and how we can seek inspiration from the cybersecurity industry to quantify these risks. Next, we are inviting Ms. Niharika to join us on the stage to deliver her presentation on reinforcing public trust through meaningful transparency, policy recommendations for public algorithm registers. We will not be taking a break right now. We will be directly breaking into lunch after the presentations.
Thank you.
Good afternoon, everyone. So today my paper is basically a policy brief for policymakers, and it has actual problems identified in one of the transparency mechanism and some recommendations for that. Our title is Reinforcing Public Trust Through Meaningful Transparency, Policy Recommendations for Public Algorithm Registers. So Ada Lovelace Institute, AI Now Institute, and Open Government Partnership, they published a report in 2021 about algorithmic transparency in the public sector, and they put different mechanisms in which public sector officials can be transparent about how they are using algorithms in their system. One of the methods was public algorithm register. What is it? It's basically a register which documents all the algorithms in use by a public administration, and it discloses the purpose, function, and impact of those algorithms on the general public or to the citizens. This can be applied at a municipal level, at a city level, or a national level. So for our paper, what we did is we did the review of our current literature, the best practices, and multiple set of existing recommendations, which was done across US, for example, Pittsburgh Task Force, and by New York City, and also in Europe. The content analysis of municipal registers in Rotterdam and Helsinki, and national algorithm registers in Netherlands. And then we interviewed some public sector officials in Belgium and Netherlands. The interesting aspect of this is we talked with 3 different categories of registers, one which are not yet deployed, the other one which are in early deployment phase, and the third one is which are much more advanced phase. There are some limitations to our approach, which can also be attributed to the fact that this kind of method is still in an experimental phase and is only tried by very few cities across the world. So our research is limited only to the European context, and what works for governments and registers usually differs across different contexts. Since very few registers are in use, so the sample size for us, for our content analysis and interviews, was really low. And just to emphasize one more thing, our approach was neither to compare or criticize existing efforts, but rather give recommendations to provide better service to the citizens and give a better approach to tackle these. So what are the challenges in first wave of public registers? We identified 4 challenges. First is quality and quantity of informations. Many of these registers lack complete and meaningful data, which makes transparency aspect not sufficient enough for journal citizens.
then these registers have a user experience which is not so friendly for citizens. Then they use a very high technical language which hinders normal citizens' understanding. And fourth, the accountability aspect, there is a need for mechanism to hold these administrators accountable. However, there is no process in place as of now. So I'll go further in detail about each of these. First is quality and quantity of information. So first, there is either the data is missing or there is lack of meaningful information which can be used by citizens. Then there are typical administration problems. For example, there is resource constraint in terms of capacity of people who can work on this and in terms of time resources. Also, fragmentation in public departments does not help in maintaining the quality of the register. Then the third aspect is lack of data literacy and digital expertise among public servants, which reduces the quality of information displayed in these registers. Fourth is, since most of this work is outsourced and the public officials are relied on third-party agency and external consultants, they don't provide systematic documentation for these registers, which reduces the quality of information provided. So our recommendations were to cultivate a transparency mechanism where they have internal policies to make sure that officials have to fill the registers meaningfully and comprehensively. And then the second aspect is training public servants on data and AI literacy. As many of our speakers talked about the Dutch scandal today, the public sector officials need to know what algorithms can do to normal citizens, and that they should be trained about this. Then our third recommendation was to have a strategic approach to consultants. So instead of just outsourcing everything to them, we suggest that a public servant shadow these consultants and then transmit the information gained from them to other players, to other officials in the department, and improve their knowledge about these registers. Fourth is assessing if there is a risk for giving too much information in these registers, then that should be specified, and why that can't be made public. It should be balanced, and it should be informed in public as well to increase transparency. The last is, which the current Netherlands ministry is trying to do, is actually have a legal obligation for public sector officials to complete these registers by law. Although we think that it's not feasible in all contexts, but this could be also one of the possibility to make sure that the quality of these registers are maintained. Then on citizens' experience part, we realized that most of the websites which are constructed are maintained from administrators' aspect, how they want the information to be seen, and hence it is not useful for normal citizens. And they also are not prepared, keeping in mind the view of citizens' lived experiences. For example, in the Dutch algorithm, when a citizen put a normal term for tax authorities, there were no hits, but if they put a sophisticated word, there were hits. So we realized that if a normal citizen can't put a word which is a common term, then there is no use for it, and that should be taken into consideration. Third is each agency see the algorithm separately, which leads to a fragmented view. And lastly, citizens are affected by multiple algorithms simultaneously, not just one at a time. So our recommendation was to have a panoramic view of all the algorithms at one place, and based for each citizen, we can have a personalized algorithmic dashboard where they can see which algorithms are affecting them in a given time, enhancing the search functionality based on the common terms used by a common citizen rather than using sophisticated terms, and improving the interface design so that it improves the citizen experiences rather than using traditional public sector or boring public sector interfaces for displaying information. Accessibility for non-experts, as already mentioned, they use highly technical language, and it becomes difficult for citizens to realize how a specific algorithm is actually affecting them. In some cases, there are also languages barriers, so they have to resort to using automated Google translation, which is not a good solution. And the last point was that some of the title entries are made are so technical, which is basically used internally with the same term in public offices but are not known to common citizens. So we recommended that there is a need for striking a balance for register entries, and they should not be highly complicated but rather should use normal terms. Second, they should emphasize what real consequence a particular algorithm can have on their life, so that should be clarified. The third recommendation is using videos for informing the public. This was used by French government in one of the local municipal registers, where they created small videos to tell them what an algorithm is, how it is working, and how it can impact them. And the last one is testing register accessibility. So taking a diverse representative pool of citizens and testing how it is working with them, and then taking feedback from that and updating it. I'll just quickly run through this. In terms of accountability, we realized that there were very less means to actually do something when you don't know if you are facing an issue with a particular algorithm, and there are hardly any avenues. So we recommended that clear responsibility should be set, and it should be defined who is responsible, so that citizens can reach out to the particular entity for readdressing the impact of the particular algorithm. Then whatever has been experienced in the previous citizen redressal process, those reports should be made public so that citizens are also aware about that. And lastly, having open and inclusive algorithm register building, so basically engaging the public, having a conversation with them, which the Dutch government did. They did a target group analysis where they asked for feedback from them and incorporated whatever the citizens informed back into the system. And I'll just conclude with this. So while doing this whole research, we realized that there are much bigger questions that need to be answered. For example, there is a clear misalignment between strategy and purpose. They are trying to build a transparency mechanism where citizens trust the algorithms which are used by public sector officials, but the information provided is not sufficient enough, so that is causing a concern. There is also a tension between being too much transparent and system gaming. The public sector officials we interviewed said that they have an issue that they can't make everything transparent because there are bad faith actors who can game the system and misuse this. So that also needs to be tackled. Then choosing between a mediated and direct system, trying to define the audience, whether they are targeting the experts who will disseminate this information to normal public, or are they directly approaching citizens. So it needs to be more comprehensible for them. Then need for feedback path loops, and lastly, understanding that algorithm registers is just part of a bigger strategy, and there is a need for building digital literacy both in the public sector and in general citizens' experience. That's all. Thank you so much.
Thank you, Niharika, for expanding on the limitations of algorithmic registers and the pathways that may be adopted by governments to address these identified limitations. Could I now request Ms. Tarunima Prabhakar to join us on stage to deliver her presentation on developing community-led AI, Notes from the Trenches.
Hello, everyone. Thank you so much for the opportunity to GPAI and the Research Symposium to give us the opportunity to present. I'm Tarunima. I'm the research lead at Tattle. We're a civic tech organization that works on citizen-led responses to inaccurate and harmful content online. I'm presenting this paper on behalf of my co-authors, Cheshta and Arnav, who are at Western Norway Research Institute and University of Copenhagen, respectively. This is a reflection of a nearly year-long process of developing an ML system to detect gendered abuse alongside people who are actually at the receiving end of abuse. And we conclude the paper by describing sort of takeaways or generalizations for generally AI systems that aim to get larger public participation. Just as some background, as AI systems have become more closely intertwined with public lives, there has been a call by both the private sector as well as the public sector to include the people who are going to be affected by the decisions of these systems, both in literally all stages, or as policy prescriptions have said, in all stages of development of the AI model. Just as an example, the Microsoft's responsible AI standards, they call for working with the affected groups that might be subject to stereotyping, demeaning, and erasing outputs. The expert group reports by the India AI Committee emphasize on open source architecture and data sets to promote transparency, interoperability, and community participation. The idea is that by involving people in all stages of the AI development system, especially in the data set creation, we lead to, or we get fairer and more inclusive AI systems. The prescription is well taken. The question is, what does this prescription mean in practice? That is what our paper is trying to describe. So we, in 2021, worked on a project called URI, which was trying to build systems to detect gendered abuse in 3 Indian languages, Hindi, Tamil, and Indian English. The motivation for this project came from 2 factors. One, that a lot of basic data sets that enable any sort of toxicity detection or systemic risk detection of machine learning systems, those basic resources are lacking in Indian languages. And second, that the amount of gendered abuse that demographics in India receive is disproportionately higher than some of the Western counterparts. So one of the features, I mean, it's a broader project, there are a lot of features that are not around machine learning, but one of the features that we developed through this project was detection and redaction of abusive content, specifically gendered abuse. And we wanted to start with the experience of those who are at the receiving end of abuse. In our case, this was activists and researchers, many of whom have responded or encountered online gendered abuse. And we started in 2021 with focus group discussions and interviews with over 30, somewhere between 30 to 50 researchers and activists across these 3 languages to understand their pain points and needs. A lot of the problems that they suggested or they surfaced did not need an AI solution. A document listing all the needs we heard at the time can be found on the website. It was specifically the feature on detection and redaction of abusive content that required machine learning. Now, just to give a sense of what that entire life cycle of an AI developer or machine learning system is, it is first, as I mentioned, the identification of needs or problem formulation. Then we have the data collection. Then there is this very tricky bit about how do you even define what abuse is. You then select annotators who will annotate the data. You annotate the, they annotate the data, and then we train the model. This is just, talking about the pre-deployment stage. There is a lot that can be done in terms of community participation post-deployment. That is not the focus of our paper. We're going to be talking about generally the practical challenges of trying to build public or community participation through these different steps. There's a bigger paper that describes the creation of this data set, where you can sort of also go through the technical details of data collection, how we sampled, etc. So since we're using the word community, I think let me just define what that is for us. As I mentioned, it is people who are at the receiving end of abuse. But we also, within this group of people, there was a significant level of heterogeneity. We had people who were, for example, not based, they might be speaking a language, but they might be diasporic community, so there was regional variation. There was different socioeconomic backgrounds, different religious caste backgrounds. And at the very first step of defining gendered abuse, for example, there was significant disagreement even internally within the team. So this box on the left side, which I'm saying are people with the experience of online gender-based violence, that's our external community. But then within the team, there were qualitative researchers, one who spoke, one for each language, so someone who spoke Tamil, someone who spoke Hindi, and someone for English. There's the data science team, there's a project management person or the team, and then there are other, this is a simplified diagram, but I'm not going to get into some of the other team members since it's not relevant to this paper. Just one thing that's important to highlight is that, when you're designing a system, or you're trying to understand how a technical system can meet the needs of an external community, it's actually a process of negotiation. For example, the qualitative researchers who are engaging with the activists, right, they might hear a need around, I hear or I get a post of, say, good morning every day on my social media. That's the language that the external community is going to express their needs in. The data science team, on the other hand, speaks the language of AUC, F1 scores, etc. And there needs to be this bridging of gap between these two sort of disciplines or these two communities that speak very different languages. For us, one of the things that stood out was that you have to consistently translate, that there is this arc of translation that goes from the technical data science team to the external community that expresses its need in a very different way. And at the same time, the data scientists might know that there are certain design decisions that need to be taken and therefore have certain questions for the external community that, again, need to be translated. And there are translation in sort of the science, technology, society world is a very contested sort of, it's a place where meaning is made, but it's also a place when meaning is fought for. So just, yeah, I'll sort of leave it at that and come back to it later. So one of the things that when we started with our annotation work is that we actually asked, we had these two questions in our annotation guidelines. So we went to the external community and asked them these two questions. One, is this post gendered abuse? And then second, is this post explicit or aggressive? What we repeatedly heard from the external researchers and activists was that gendered abuse is highly contextual and that the rubric that we had provided was limiting. But the reality is that any ML model simplifies context and it relies on categorical or often binary variables. And this knowledge might be something that data scientists take for granted, but it is not information that we should assume that the community knows by default. So we have to explain the limitations of what machine learning can and cannot do, but also we have to take their feedback and then we expanded the rubric the best we could while also being mindful of the labor that goes into into this work, and we came up with these three posts of is it gendered abuse, is when it's directed at a person of marginalized gender, when it is not directed at a person of marginalized gender, and whether the post is explicit or aggressive. What is the table on the right is actually the agreement scores. So we had 24,000 posts labeled by 18 activists, 6 who spoke each language. And what we notice is that not only is there relatively low agreement, so when multiple people annotated the same post, they often disagreed on whether something was abusive or not, but also that there is variation across languages, right? So for example, in Tamil, score closer to 1 means that there's more agreement. In Tamil, you actually see that there is more agreement. People are more likely to agree on whether a post is explicit or aggressive than in Hindi or English. So just to sort of extrapolate back up, we think that what is also very clear from that table is that what I had mentioned earlier is that we can't think of communities as homogeneous. It is sort of interesting, and it's an open research challenge on how you actually include the variations or the of perspectives in decision making when you're trying to include community. One of the ideas suggested is public juries, but we have to be careful about this idea of majority decision making because often the minority or the dissenting opinion expresses some contextual awareness that is important to capture. Second, as past research in technical and infrastructure projects or engaging participation in technical infrastructure projects is highlighted. It's that overly technical information can be a huge stumbling block to meaningful public engagement. Having said that, you can't wish away the technical nature of machine learning, which is increasing in complexity and is sometimes inscrutable even to the engineers who work on it. So we need to think hard about that arc of translation that I described earlier, and that's an open research question for us. Third, that attempts at increasing participation can backfire, because when a community is battling marginalizations on multiple fronts, getting familiar with technical details might not be a priority. And so the motivation to understand the process is also contingent on how important they think that decision is in their life. But we should be wary of this idea of participation fatigue. And so relatedly, a certain degree of opaqueness seems inevitable. All the people or your external stakeholders might not understand the models that are used to train the, or might not understand the technical mechanics of a machine learning system. But then the question still remains that what then leads to trust? If we feel like there are going to be limits to transparency and there are going to be limits to deep engagement and at an equal level by all people involved, what leads to trust in that system? What we found was that a lot of it actually comes from the existing relations of trust with the organizations that are stewarding the process. People will often look for proxies of trust. So they might ask questions about who is funding, what is the history of success or history of actually honoring public participation in past projects. Second is that we actually found that the compensation, the monetary compensation of time spent was an important factor for them. It might not have been stated explicitly, but people feel that there is some recognition of the time that someone is devoting to give their expert opinion. Three, we also feel that procedures of transparency and accessibility, even if most people will not engage with them, are still important. And this is a lesson that also comes from open source movements, is that in our case, for example, we were sending newsletters to 50+ people every month, and it was usually just the same 3 people who would come back engaging with the work. At the same time, when you meet people, they actually appreciate that they had the possibility, even if they did not exercise the option of engaging or trying to understand how the project or the machine learning model was being developed. That's it for us. Thank you so much. Yep, I'll hand it over. Thanks.
Thank you, Tarunima. Thank you for this insightful presentation and expanding on the inspiring work pursued under the ULI project. Now I invite Mr. Adarsh Srivastav for his presentation on assessing the trustworthiness of generative AI used for higher education. I am pressed to request you to stick to the time limit, because we'll have to break for lunch soon.
Thank you. Thank you. And I'll try to stick with the time.
Thank you.
And since morning, the word which kept popping up in this today's session is trust, and I'm going to reinforce the same thing in the session. To start with, the presentation is not there.
It should be on the...
It is in my laptop, but it's not there. Okay. Okay. Thank you. Okay, so first of all, very quick introduction. I'm Adarsh Srivastav. I'm head of data and analytics quality assurance. I work for Roche, which is a Switzerland-based healthcare company. And 3 years ago, I've been tasked to develop this competency of AI ethics in the organization. And what I realized is this is something which is going to be very important, and especially important for a country like India. And I decided that I'll take this knowledge which I'm gathering and then do something for the country. And that is where this paper comes in. So I'm presenting this paper on behalf of my co-authors, Gokul and Ishwar. They both are in the hall today. This is the team. I'll very quickly go through the team and you'll come to know why I'm presenting the team in the start. This is one thing which I really want to tell about from this slide is, apart from me, Gokul and Ishwar, who are the co-authors of the paper, Divya is coming from a legal background. She is she's a practitioner lawyer in Supreme Court, and Dr. Vinayak is from the teaching background. Roberto Zicari, and then Roberto Zicari is a professor who is based out of South Korea, and then we are using his framework. Okay, so very quickly, summary of the use case. We are trying to assess the trustworthiness of a generative AI-based application which is being used in a Indian university, D.Y. Patil College of Engineering. It is based out of Pune. And what we are trying to do is to take this as a use case and then map it with the trustworthy assessment framework, which in this case we are using Z-inspection as. Very quickly, the key area of this solution, the use case is that this college is using this generative AI-based application solution to map the course outcome with the overarching program outcome. So be it a bachelor course, be it a master course, they are using this solution and then taking help of these LLM solution to map the course outcome with the overall end program outcomes. And they're also using this AI application to generate tailored teaching materials and methods. And then what they're planning is in future, they're going to use the same application, same solution to create engaging and learning materials on top of it, create rubrics and assessment which is kind of gamified, and then it have varying difficulty so that based on the assessment, the college can help their students individually. And this, so we talked about the use case. This is the trustworthy assessment framework which we are using. So there are lots of framework available, but we picked Z-inspection framework because I worked with Professor Zikari for a long time, and then this is his brainchild, and then I found it very flexible. And in a very, in a nutshell, there are 3 phases in this framework: setup, assess, and resolve. And before moving ahead, I just want you all to know that this research is not concluded yet. We are in an ongoing research. So we are right now in the assess phase. What we did in the phase 1 is to set up. There are preconditions which are set up. There are team which is collected. And then we are into the analysis of the socio-technical scenarios. And what we are trying to do is we are generating the socio-technical scenarios. We are asking questions. We are creating a list of ethical tensions that can come out of the use case. And we are trying to map these ethical tensions with these 7 requirements which are mapped to the European Union Guidelines of Trustworthy AI, which is there in the Map to Trustworthy AI section. And why I said that it is, we preferred Z-inspection, because what we are also trying to do is to use the same framework, and we are trying to map it with Indian guidelines for trustworthy AI as well. And then it can be done. We are in the process of doing that. But for now, for this research, we picked the European Union guideline for trustworthy AI, and all the ethical tensions which are coming out from the socio-technical scenarios and the analysis are mapped to these 7, which are very standard: human oversight, technical robustness and safety, privacy and data governance, transparency, diversity and fairness, sustainability and accountability. Sustainability is something which we are very interested in, because this is going to be important when it comes to the carbon footprint of the generative AIs and the solutions which we are developing on top of it. With the setup, I'll go through the phases which we completed and where we are moving. As a setup, what we did is there's a precondition phase where we understood the use cases directly from the actors and the stakeholders. We conducted interviews with the college facility and the development team who developed this generative AI-based solution. And what we did is, based on the understanding, based on input, we started forming an interdisciplinary team from diverse backgrounds. So there are people, I'll come to that later. Apart from that, we also created a entry criteria and entry criteria. Where are the boundaries? What are the things which we are not going to look at? What are the things which are actually important for us to successfully conduct this research? And then in the end, we set up a cadence where we met regularly, the team met regularly, and then we started formalizing the socio-technical scenarios which are being used in this AI systems. And to further simplify the process, we created a working group because bringing such a diverse team and then asking them to start formulating their socio-technical scenarios, we created a work groups where we bifurcated everybody into a specific group where the technical people are in a technical working group, and the people who are expert in ethics goes into ethics. And then there's because this use case is education based, we have ethics from education perspective as well. Teaching staff who is actual user of this system, legal law, because we wanted to have that perspective also, whether it is something which should be used. And then at the end, we also created a working group for the student representative, because this solution is ultimately impacting them. What we are doing as of now is analyzing the socio-technical scenarios from different viewpoints. This interdisciplinary team, they meet regularly, they have their own questions, they have concerns, and then they are getting resolved by the stakeholders. And based on the resolution which they have, we are creating ethical tensions. And these questions, these scenarios are revolves around what is the aim of the use case, what is the end game of this use case, what are the expectations, what is the technology and the context which is being used, ecosystem in which where we are developing, and then there are what will be the action taken to assess the issues when it comes. And currently we are into this phase. Once the ethical tensions will be mapped, we are going to map those ethical tensions to the EU guidance on trustworthy AI, and then start resolving them. And the tensions which are not resolved, or there's a mitigation step which will be there, we are going to form a report which will be given to the stakeholders, in this case DY Patil College of Engineering, for them to resolve it in due time. And maybe down the line we will redo the same exercise to find whether the ethical tensions which was given in the previous report has been resolved or not, or is there any other ethical tensions which are getting arise with the new way of using the same generative AI system. That is it, I think. Yes. Thank you, everyone. Patiently.
Thank you, Mr. Srivastava, for this very insightful presentation. And yes, now I'd like to invite Mr. Abhishek Raj and Mr. Harsh Singh, both from Microsafe Consulting, to present their paper on harnessing the potential of AI for Indian agriculture, leveraging Bhashni as a tool for deploying responsible AI and increasing uptake of AI applications among farmers.
Hello everyone, a very good afternoon to all of you. My name is Abhishek, and I am joined by my colleague Harsh and Anshul, who has joined virtually from DC. We work in a social impact consulting firm called Microsafe Consulting in their Center for Responsible Technologies practice group. We are here to present our policy brief on harnessing the potential of AI for Indian agriculture. In particularly, we talk about AI-powered chatbots and how to leverage Bhashini, which is India's local AI-powered translation initiative, to increase the uptake. So yeah, let's get started. So as all of us know, the population across the globe is increasing. This puts agriculture sector under immense pressure. So the only way to tackle this pressure is to increase productivity, because obviously we can't get more land under the cultivation. So this becomes important for India as well. Also, apart from the food security, agriculture is important to India because it employs 45% of the India's workforce. So in order to increase productivity and deal with uncertainties such as weather uncertainty, market, Indian farmers resort to agriculture extension and advisory services, which is basically the knowledge database for them to deal with uncertainty and increase productivity. These are important because 86% of the farmers in India are small and marginal farmers. So these extension services are delivered basically through extension workers or through SMSs or through IVRS systems. So, but again, these extension services have certain limitations, such as extension staff has a shortage. Like for 1162 farmers, there is one extension worker, plus the SMS and IVRS are centralized advisory, which is not suited to the local context, right? So with the growth of the technologies such as AI, particularly the generative aspect of AI, this AI-powered chatbots could help to customize and personalize the recommendations for the farmers, and also reduce the query redressal time. And also with the coming of Bhashini, which is local language translation initiative, the linguistic barriers can be broken down.
To identify the barriers in the uptake of AI-powered chatbots for agriculture in India and provide recommendations, we undertook a study to understand the current ecosystem of players. We focused on 4 case studies in India, namely Ama Krushai, Jugalbandi, Kisan E-Mitra, and Kisan AI, to understand the challenges faced in scaling these innovative solutions among farmers of India. We undertook secondary research and engaged with multiple stakeholders such as agriculture experts, farmers, solution architects, academicians, and government officials. This became the basis of the identified challenges and recommendations provided in the further slides. As you can see on the screen, these are some examples of AI-powered chatbots. On a very high level, these chatbots are trained on datasets and then use translational models like Bhashini to take and deliver the response in the end user's preferred language. Let's look at these. The first one, Ama Krushai chatbot, is positioned as India's first AI-powered chatbot in India, and it comes under an ambitious program known as Ama Krushi, which is run by the state government of Odisha. It leverages ChatGPT and its own data set that has been trained on government data, and to provide the farmers of the state with agro advisory, information about government schemes and loan products. It is currently in nascent stages, and the first pilot is running with 10,000 farmers. The second one is Jugalbandi, which is a collaborative effort between Microsoft Research, AI for Bharat, among others, and is an open source API with multiple use cases. In the context of Indian agriculture, it can be initiated through a text or voice message through WhatsApp. The text-voice query made in any of the supported user language is translated into English by Bhashini, and then vice versa for the response. Currently, Jugalbandi supports 10 of India's 22 official languages and provide information about government schemes to its users. The third one is one of the first chatbots that was launched by the Union Ministry of Agriculture and Farmers Welfare. This was for the effective grievance management under the PM Kisan scheme, which is a flagship scheme under the central government. The E-Mitra chatbot is currently available in English, Hindi, Bengali, Odia, and Tamil, and helps the beneficiaries with their queries about application status, payment status, and other grievances. Coming to the last one, which is definitely not the least, and so Kisan AI, that is a product of private sector innovation to assist Indian farmers and provide real-time advisory on irrigation, crop, and pest management, among others. It utilizes ChatGPT 3.5 along with field data that is collected through various agricultural research universities. Currently, it supports 9 Indian languages and plans to add Assamese and Odia in the future. So now, let us look at the barriers.
So talking about the barriers, so first barrier that we could identify was these chatbots in its present state do not have contextual responses. We have an ongoing pilot with Kisan AI among farmers of Bihar, and the farmers have said the responses are often generic in nature and lack context. This is also because India is divided into 127 agroclimatic zones, and every zone has its unique characteristics. So it becomes difficult to contextualize the response. Again, apart from the context, the biggest challenge is of trust. Farmers don't trust these AI chatbots as of now. Because of the obvious reasons, out of context responses, plus also they have their traditional knowledge system that they rely more upon rather than these chatbots. The second challenge that we could identify is linguistic diversity and associated training challenges. As we all know, India is a linguistically diverse nation with around 120 languages and then multiple 1400 around rationalized mother tongues. So it becomes difficult to gather data and train those AI models for achieving the translation. Also, the literacy level among farmers is on a lower side that necessitates the requirement for a speech-based interface. Then again, that has again the challenge of training the model and getting the data for low resource languages. The third barrier that we identified is on digital connectivity and behavioral gaps. Although India has taken a leap forward in achieving connectivity, but still a lot of rural population, especially farmers, don't use the internet actively. Also, they lack the digital skills and the knowledge about the benefits of these systems. And last, the ownership of smartphones is also on a lower side. The fourth barrier that we identified is the resource gap. So as 86% of the farmers in India are small and marginal farmers, which means they have a low individual buying capacity. This becomes important for the private sector applications that may come up with a subscription cost or user charges. Also, in terms of availability of resources to act upon the advisories is limited, because even if the farmers get the advisory on time, then they don't have the resource to act upon the advisory. So, based on these barriers, and we tried to formulate certain recommendations to increase the uptake of the AI-powered chatbots for agriculture. So first recommendation that we suggest is to enhance the contextual training of the models. So this can be done in multiple ways, like collecting data till the village level and establishing dedicated wings under state agricultural universities to collect data, and something sort of agricultural glossary for the crops, what they are called at the regional level. And the advisory can be customized, say, based on the time of sowing. The sowing time for every farmer differs. So if the farmers get the advisory based on their sowing time, then it will be more beneficial for them. Again, the second recommendation is on encouraging collaboration and partnerships. This becomes important because in India, what happens, state agriculture universities have all the data related to agriculture, but they might not have the capacity to build a chatbot or run a chatbot. But again, the private sector has the capacity, but they don't have the data. So if the data sharing happens in a responsible fashion, then it can increase the uptake of chatbots. And also, local NGOs can be involved to train the farmers and everything. A good example in this regard is the Plantix app, which is there in Andhra. So it has collaborated with Andhra's Agricultural University to get the data. The third recommendation that we suggest is always keep humans in the loop, because farmers as of now are not very much capable of using these chatbots on their own. So which means they will need someone to train and upskill them. And also it increases trust because of the human touch involved. And something sort of agent-based model can be thought of in the agriculture sector, like similar to what is happening in the finance sector. The fourth recommendation we suggest is on taking the regular assessment. This becomes important because often these apps have the offerings that are not needed or that are not suited to the farmers. So the regular assessments need to be done to identify the gaps between the needs and the offerings. The final recommendation and the most important recommendation is to ensure data protection and privacy of the farmers, because in the coming decade, there will be a lot of farmers' data collected, and that can lead to indiscriminate uses also. So we need to ensure that the data is used in a responsible way, and if data sharing happens, that should happen in a responsible way. So to conclude, we're not saying AI chatbots can do everything for farmers, but obviously it is a good complementary mechanism to fill the gap in the existing extension services for agriculture in India. So yeah, this was from our side. Thanks for listening to us patiently.
Thank you.
Thank you.
Thank you, Abhishek. Thank you, Harsh. Now, I'd like to invite Dr. Mona Duggal on the stage to deliver her presentation on responsible adoption of cloud-based artificial intelligence in healthcare, a validation case study of multiple artificial intelligence algorithms for diabetic retinopathy screening in public health settings.
Good afternoon, everybody. I think this is a showstopper. I think this is kind of the culmination of all the work and all the talks that we had heard. Even if you look at the abstract book, interestingly, we had the largest number of authors. It is a collation of public health experts, technical experts, policy, and implementation science. That is kind of the use case, which is probably one of the most unique studies that has ever been done in India. It's not going. Quickly, I'll go over the rationale, methods, findings, conclusions, and recommendations. As we all know, in last year, we have around 101 million people living with diabetes. We have the second largest number of adults with diabetes. Uncontrolled diabetes can cause complications like diabetic retinopathy, and as of now, 50% of the population is undiagnosed with diabetes. Of this, the most common complication is diabetic retinopathy, and it is a leading cause of blindness among working age. Prevalence across states varies between 18 to 34%, and early DR management can reduce up to greater than 95% of blindness. Before I even go to the next slide, just to give you a context, we have the eye. What is diabetic retinopathy? Just so that you understand where we are going from this. The back of the eye is the retina, and in the retina you have the blood vessels, and if they are damaged, there's called the diabetic retinopathy, and they are different. There's a grading system. There are signs that you need to detect for you to call it as diabetic retinopathy. How do we actually diagnose a case of diabetic retinopathy? The most common case used is the image analysis. That is the fundus photography. So we have to do a fundus imaging of the retina to get to diagnose a diabetic retinopathy. What are the current challenges? Given we have a huge population that we are looking at, and it is an epidemic, so what is required? We require regular retinal screening and expert human grading of retinal images, and with limited number of trained graders and ophthalmologists, it's an extremely challenging situation. We also have been talking about needing to integrate screening due to increased diabetes prevalence. Sure enough, we have a solution. Whoa, we have AI, right? So when I think I started working in this space, there were like a couple of DR algorithms that were there to detect AI. And the talk was on for the integration of validated AI algorithms into existing health systems. It has already been successfully integrated in countries like UK and Scotland. We have several pilots across the country where we have been successful in using this as use cases. It also helps in enabling the non-eye health professionals to perform opportunistic DR screening. But what is the catch? Can it be integrated at this point? Can it be used for mass screening? And this is where the story begins and why the study is important. Validate is the word which is the key. We always said validate. And when I started this project, we went to Niti Aayog. We were asked to integrate a validated AI system under an Indo-UK system in a state of Haryana. And I still remember at that point, we were stopped and said, how did you say this is a validated system? Of course, the company was asked to provide the Indian data in the Indian context. And sure enough, that company never came back because there was no data in the Indian context to show that the system had been validated, to show that this system works in the Indian settings. 2 years down the line, we were contacted again, And as a part of the Atmanirbhar Bharat Abhiyan, the objective of the pilot was to validate the performance of Made in India AI algorithms for DR screening. Second was to evaluate the feasibility and acceptability of integrating validated AI algorithms for DR screening in public health systems. Lastly, to assess the responsible adoption of AI algorithm. The pilot was conducted in Mohali during the COVID times, where we validated the AI systems, and then the feasibility and acceptability in the aspirational district of Moga. I will be focusing only on the validation part. Feasibility and acceptability is another story. This was the validation procedure. So this is a commonly, if you look at any health journal, that is where most of the AI systems have worked around. We are going to be looking at the sensitivity, that is the ratio of positives to true positives. Specificity is the ratio of negatives identified that are actually negative. Negative predictive value, positive predictive value, and the kappa statistic against the gold standard. Generally, the accepted standards in screening, it has to be 80%. Higher the sensitivity, but a good specificity is required. Another catch in the DR screening, which most of the people never say when they are coming for selling their platform, is DR screening has to be done in the community. As per the rules of the ophthalmologist, if an ophthalmologist is not present, we do not dilate the eyes because there is a risk and an emergency situation can occur. So you cannot dilate the eyes if an ophthalmologist is not present. So most of the images that are taken in the field setting as per the Indian guidelines has to be non-mydriatic. So having that background, we come to the next slide. Through Niti Aayog, we scoped which are the AI platforms around. We invited quite a few. 3 agreed, and one was an AI platform that was FDA approved. So we had 3 Indian AI platforms. One was an FDA approved AI platform. When we looked at them across, none of the AI platforms had a uniform outcome. Every AI platform was giving a different outcome, which was not according to the ICO guidelines or the guidelines where we would say, okay, we are grading it according to the diagnostic performance. To keep it uniform and so that the screening is yes and no, whether you have diabetic retinopathy, so you have a timely referral, which goes with the community, we decided to make a uniform outcome that is yes and no. Based on that, we asked the algorithms, the participating algorithms, to send in what they said was their sensitivity and specificity. As you can see, all the algorithms said it was greater than 90%, both sensitivity and specificity. We took those algorithms, we talked to them, how the data was going to be shared, everything was charted out. We validated the systems in a system that is like in a community system by a highly trained non-ophthalmologist in the community settings. And the sensitivity and specificity that came out was, sensitivity was 60%, between 60% to 93%, and specificity was between 14% and 96%. The AI that was FDA approved, that dropped out because they had like approximately 99% sensitivity and a specificity of 4%. They decided not to go ahead with the study. We try to adopt all the processes of responsible adoption, ethical approval, trial registration, formulation of a project advisory group, training of a non-ophthalmologist to the level of an ophthalmologist in taking the images, establishment of a darkroom, low cost, good quality, non-mydriatic, made in India, fundus camera to ensure inclusivity and where the states can procure. And it is generally the state said, if we have to start the program, it has to be less than 10 lakhs. Consent and recruitment of the study participants, data management for storage, storing and segregation. It was done on the Niti server. Image gradation by 3 graders, which were all certified, and the 3rd grader was for the break in case the 2 graders did not agree. Conclusion was, do we have AI explainability from the sets, information on the training data sets available? information on the intrinsic evaluation and fine-tuning of the metrics data, and lastly, information on selecting the most optimized parameters for uniform grading the results. I'll not go over the rest because there are a few other slides which I need to go over. My team asked for data set details for all the AI platforms. As you can see, it was not uniform. The number of images was not uniform. Race and ethnicity was across. So, generally for two AI platforms, it was Indian. One, it was Indian, Asian, and Caucasian. Cameras were across. And the photographs, who was annotating and how they validated it was not there. This was overall interpretation of the quality of the data shared. Last, we went back to the AI companies and whether they adhere to the principles. This was what they said. We started going out to the market, conducting camps on our own. During the entire process, we screened more than 94,000 people till date, and there are no ethics requirements to conduct the camps. AI development, there's no compulsion to have any ethics clearance for training our data sets. Ethics around data usage for AI development is still gray, so we don't have any good deal of clarity in this entire aspect. Legal experts concurred. Right now, AI companies are quickly creating large data sets. They are self-regulating and saying we are anonymizing and not revealing it to the public. We don't want to get into trouble. Regulatory policy regulations are vague or gray and not completely well-defined and not completely tested. Recommendations: we need access to high-quality and trustworthy data, robust data governance and privacy frameworks, AI upskilling, reskilling for digital workforce transformation at the 3 Ps levels: policy, program, and population level. With that, I conclude. I want to acknowledge the entire team, of course, and of course, specifically Dr. Vinod Paul and Ms. Anna Roy, who actually conceptualized and helped us to do this project. And with that, I thank everyone. Thank you.
Thank you, Dr. Mona Duggal. Thank you to all the presenters for joining us today and delivering your presentations in person and virtually. I'd also like to thank the hall coordinators and the team from NEGD and DIC who helped me coordinate this entire event, particularly Satyavir sir, Raghav, Ankita, Kanika. I'm really sorry if I've missed out on any of the names. I'd also like to invite Professor Ravi on the stage, along with all the authors, to share with them the mementos and the gifts that we have for them. Thank you so much. You're more than welcome to join us on the stage. Thank you. Can we have a round of applause for all the authors? Thank you so much, audience, for joining us and staying till this time. members of the audience are requested to join us for lunch in Hall 14. And speakers are requested to join us for lunch in the delegate lounge. In case there are any issues in identifying which one is which, you can reach out to us. Satyavesh sir is here, I'm here, and we'll be more than happy to guide you.